one. Everyone. I'm Dr. Grace Lagat from University of Eldoret, Department of Chemistry and Biochemistry. I want to most sincerely welcome all of you to this meeting. It's our third day of Chemical Science Conference, and I want to appreciate all participants who are following virtually and those who are physically present. We appreciate the time you are taking to be with us. So we're going to start off our meeting, and I'll request all of us to rise up for the anthems, and then we'll have a prayer from Mr. Alex Rotich. Thank you. National anthem. Yetu ilete baraka kwetu, haki iwe ngao na mlinzi, na tukae na undugu, amani na uhuru, raha tupate na ustawi. East African anthem. Ee Mungu twaomba ulinde Jumuiya Afrika Mashariki, tuwezeshe kuishi kwa amani, tutimize na malengo yetu. Jumuiya yetu sote tuilinde, tuwajibike, tuimarike. Umoja wetu ni nguzo yetu, idumu jumuiya yetu.
Before this morning, we want to thank you for the gift of life you've given us. We want to thank you for the leadership that you've led us since we started our conference on Wednesday till this day, oh Father. We won't forget to say thank you, Father, for today's sessions, and we want to put before you all the speakers for today, oh Father, that you may lead them and will be gracious to your name, oh Father. I pray this, trusting and believing in Jesus' name.
You may be seated. So welcome again, members, to our third day. Today we're going to start with the parallel sessions. So we're going to break into our break rooms for 1 hour. That is from 9 to 10 a.m. Then we will all converge for the keynote speech from 10 to 10:40. Our keynote speaker is going to be Professor Rajeshwara Achur, and the sooner we are done in our parallel sessions, we will invite our speaker to take us through. Thank you so much. May we break to our rooms.
Okay, thank you very much, Dr.
Langat, are you comfortable uploading the slides from your side? From your Langat, please, is it possible for you to upload the slides from your side so that you can run them smoothly? You're muted, Langat, please.
Okay, let me upload, then we can continue.
Thank you. Okay, there we go, Langat.
Oh, thank you very much.
Yeah.
Yes, my name is Langat Kipgetich. My university supervisors is Professor Jacob Itop and Dr. Julia Sichka from Department of Mathematics and Computer Science of University of Eldoret, the School of Science, led by our Apple Dean, Professor Samuel Luther. Welcome to my presentation. And this is my first presentation in academic field. Move to the next slide. The title of my presentation today is the numerical simulation of the effect of velocity and diffusion coefficient on concentration of contaminant in a fluid flow. Next slide. The abstract. The study develop and implement the explicit scheme for solving one-dimension conventional
Hello, Langat, are you there?
of contaminant in the fluid flow. Solution. Yes, I'm.
Yeah, check where you get good network, because your network is not stable.
Okay. Thank you, madam. Let's continue with the abstract. The stability of the scheme was analyzed, and the accuracy of the solution of contaminant transport equation was validated by the exact solution. We're going to use graphical illustrations of the solution by varying the velocity diffusion coefficient is given. The explicit method involves one unknown on the left-hand side of the scheme, while implicit methods involve several unknown on left-hand side of the scheme. The developed numerical scheme was developed and the MATLAB was used to generate and analyze the results. The results show that the concentration of contaminant increased inversely with the fluid velocity and directly with diffusion coefficients. Therefore, for proper treatment of water, for example, it is necessary to increase the flow velocity to reduce the concentration of contaminants. Let's go to the next slide. Let's move to the next slide, madam. Move to the next slide.
Next slide. We on the slide of mathematical model of CDE.
Okay, there's one slide that we have jumped, but let me state it. The statement of the problem that we have several authors have solved the confusion diffusion equations, but to me, we have want to analyze. They never analyzed, none of them have analyzed the effect of velocity and the diffusion coefficient of concentration of contaminant through porous medium by numerically solving the parabolic differential equation using fine different approximation. Now we move now to the slides that we have the mathematical modeling that we are going to use is the equation 1.1, whereby CT represents the time derivative of concentration, plus we have the mu, which is the velocity, fluid velocity, and Cx is the first partial derivative of concentration, is equal to diffusion coefficient with the second partial derivative of concentration. So this is the model that we are going to use with three methods that we are going to present, solving this equation 1.1. Under the conditions, boundary conditions, we have the concentration at xt is equal to the square root under 20 plus t plus 20 exponential of negative x minus 2 minus 2u square divided by 4D into T plus 20. So those are the boundary conditions that we have. Move to the next slide. Thank you. We have also the related boundary conditions on the left side. When X is 0, if you substitute now to the initial boundary conditions, we are going to obtain the square root under square root of 20 divided by T plus 20 exponential of negative 2, negative bracket 2 plus UT square divided by 4D. In the right boundary conditions, when also the concentration when the condition that we have is will give when Tx is 0, we have the right boundary condition of the related conditions will give us the equation 1.5. We move to the next slide. Thank you. Whereby the function x and g, the function of t under the xt is unknown. The function of concentration are to be determined using the facilitate method used with assumption that the constant velocity and diffusion coefficients are positive. And these are the parameters that we are going to investigate using our model, the equation 1.1. We have the objective on T's. We have the general objective is to analyze the effect of velocity and diffusion coefficient in concentration of contaminants in underground water using the numerical simulation model. To this conference, we are going to present only two objectives. And number one is to analyze the effect of velocity on concentration. 2 is to analyze the effect of diffusion coefficient on concentration. Move to the next slide. The first methodology that we are using is the implicit backward Euler methods. And this implicit Euler method is the best method because of unconditional stability. The stability conditions also was derived by the Diacan 205. The stability, the word stability we are using here is the relation between the mesh size of delta x and delta d beyond which the schemes will not hold. If we replace equation 1.1 with partial derivative with respect to t with backward, first and second derivative with respect to x with central, we obtain equation 1.1, where k is the variable of time and I is the variable in x. So we move to next. This is the mass method that we are going to use. Multiplying 3.1 on both sides with delta t, we obtain equation 3.12. Rearranging, we have equation 3.13, whereby we can divide the alpha to represent the velocity delta t divided by 2 delta x, where beta is the diffusion coefficient delta t divided by delta x square. And these are the ratios of stability. So replacing the alpha and the beta in equation 3.1 will give us equation 3.4. So if we move to the next slide, we have rearranged the equation 3.14 will give us 3.15. So further rearranging Equation 3.5, we have equation 3.6. Dividing now 3.16 on both sides by the negative, we have equation 1.17. Further rearranging, we have equation 3.8. Now, rearranging 3.8, we get this, and this is not the fashion. Equation 3.9 is the implicit scheme to be programmed. So this is the simplest fashion of the equation 3.1. It is a first method we can use. Second method. Now, if you use the results of this first method in this section, also that it shows that in this section, the presentation analysis of numerical solution was made. And it shows that the numerical computation are performed using the uniform grid with a mesh with delta x equals 0.1. The results was obtained, the schemes developed was generated by the MATLAB, and this is displayed using the graphs in one dimension. This is the result. That is in table 1.2. The table that I've given. We have to, we can refer to that table. We have the exact method, we have the explicit method, and we have implicit method and method of line. So those are the methods that we can have, but I've explained only one method, that is the implicit method. So move to the next. We have also variant. When we are varying the velocities, the one is when the velocities was 0.8, another one is 0.9, another one is 0.1. We have now to the graph.
Hello, Langat.
You are still. Yes, can move to the next slide, madam.
Thank you.
Now, this is the graph that will show that the implicit Euler method coincide with the one with the red, and it's a one with the greens. It coincide. This shows that the implicit backward Euler method agree with the exact method. This shows that this method, the implicit method, is stable, can be used because it coincides with, you compare with the exact method. But if you compare with the green ones, that is for the explicit method. It is far from the exact, and also the method of line is below, and it is giving a curve. So if you use a range of 0.1, it's because we are using the exponential graph. If you are using a small range of values from 0 to 1, it gives a straight line. But if you use a large value from negative, and for example, -1 to +1, it gives a curve. So also, if you use a velocity of 0.9, it also gives us the same. It gives us also the same solution. Velocity. So it's sure.
Langat, you're losing you.
As we the concentration of contaminant loss, you check on the concentration in y-axis in milligram per liter. It shows that as we increased, if we fix, for example, you can go to use a tape. If you use we're going to do it shows that as we increase, let me explain also that if there will be any question I will answer. As you increase the velocity, the concentration of contaminant in the channels, it reduces. So it reaches a point whereby if you want for proper treatment of water, there is a point that we need to know. Because if the flow of fluids is moving, the discharge of like sewage, so they must not to treat at the initial point. They must first of all they come in water, but as it flow moving in a channel, the concentration of contaminant reduces. So they must be a particular points whereby we need to put so that it assists us in the filtration of the process and the cleaning of water, so that all of us we can have the clean water which assists us also in this food security. Because if you don't have something which is good for us, even our bodies need to food. So if we take the contaminations of anything for water, for foods, which is not treated, it damage our body. So move to the next slide. So we want to so figure 1 show the comparisons of method of analysis. A, when the initial velocity is 0.8, B 0.9, and when velocity is 1, is given at a constant time at 1 second. Move to next slide. The figure 1 above clearly show that as the value of flow velocity increases from 0.8 to 1 meter per second, the concentration of contaminant decreases. The implicit and exact method coincide linearly in zero range, in a range of 0 to 1, while the method of line and explicit method are nonlinear in the same range. So the method of values of concentration clearly show that there is general nonlinear increase of concentration with decrease in velocity because of the truncation area due to disintegrations of the space variables and due to the round-off errors from the sulfur. The scheme portrays small effect of concentration of contaminant as the fluid increases compared to other scheme. Move to the next slide. The rate of increase of concentration are nearly at the same. Taking at, for example, at x equals 0.1 meter, the difference rate of concentration of contaminants is 0.02 milligram per liter to 3 decimal. The explicit scheme value have a highest effect of concentration of fluid velocity decrease compared to the scheme. This shows that
Langat, I think you need to conclude.
As the value of decreases. Okay, can move to the next slide. In conclusion, the study has successfully developed and implement the numerical simulation using the implicit backward Euler method, explicit method, and method of line schemes from 5 different methods. And this show the effect. Number 1, as the velocity of the flow increases, the concentration of contaminant decreases. That is the first one. And the second is can have other researchers also can have to show what is the effect of the renal numbers of concentration, and also to use fine element method for simulations, and also others can research on the effect of the same parameters we are varying into dimension. Otherwise, I want to say, move the set, say thank you, and thank you for the chemical team for having this conference. Thank you very much.
Thank you, Langat, for your presentation. Without wasting time, I will open the floor for one or two questions or comments or suggestions on Langat's work. Yeah, so anybody, you can raise your hand or speak up. Hello, anybody who has got a comment on Langat's work? I know it's complex mathematics, but the bottom line is he's trying to ensure that we have clean water for food security. That's what I got from his presentation. So if there's no question, I think Langat, I'll just say thank you to you, and I hope that next time, there's one, Felix Rotich, you can ask your question to Langat.
Okay, thank you. Mine is not a question as such. I want to thank Mr. Langat. We are in the same field of mathematics, and today he has presented it very well. I want to take this opportunity to thank him for the good work and wish him all the best. Thank you for all listening. I know the concepts of mathematics are quite complicated, but we are with him in this field. So thank you, and have a nice day.
Thank you, Felix. Yeah, so if there's nobody else, we go to the next presenter. It's which date? Is Festus in?
Yes, I'm in.
Festus, you can put up your slides. Present on influence of alkali concentration on the correction of behavior of reinforced mortar containing calcinide, clay brick waste, and coconut shell ash. You're welcome, Festus, for your presentation.
Thank you. I want to thank you for inviting me for this presentation. I'll be presenting one of the...
Festus, please increase your volume.
Yes, I'll be presenting one of my objectives in a PhD topic, influence of alkali on corrosion behavior on reinforced mortar containing calcined clay brick waste. Those are my co-workers, Mike and the rest. Reinforced concrete is the most commonly used construction material worldwide, but several problems can affect the matrix in terms of durability and even the source of deterioration of reinforced structure is usually corrosion. Affects durability and service life as a result of reduced steel cross-section, cracking, spalling, which may lead You are not hearing. Oh, yes.
Now we can hear
So
you
this
clearly.
may affect. Okay, this may affect. We have enlarged the. This may affect the structures, and as a result, we can have collapsing of some structures. We already know that ordinary Portland cement, which is the conventional cement, is highly vulnerable to aggressive environment. One of the aggressive environment that I'll be talking about is the chlorine ions. That is the hydration of OPC. In the hydration of OPC, there is production of calcium hydroxide, and the literature shows that 20% of the product is calcium hydroxide, and the calcium hydroxide provides hydroxide, which the ion exchange. These ion exchange, one of them may be chlorine, that when it penetrates into the mortar, especially the reinforced mortar, reaching the reinforced mortar, it does affect the pH. You remember calcium hydroxide is basic, so the moment OPC undergoes hydration, it produces calcium hydroxide and provides it between 12 to around 13, which is so high that provides pacification of the reinforced, preventing them from corroding. So in the event chlorine penetrates, being carried by the hydroxide in the OPC, it lowers the pH, and as a result, corrosion progression can pick up. Another product is calcium aluminate hydride, which is also an active point for an aggressive ions like sulfate, carbon, and the rest. So, corrosion, which is a detrimental to reinforced bars, we have said that once the chlorine enters into reinforced bars, it does attack the oxide layer, which is the passivation layer of the iron oxides, the gamma iron oxide, the iron tetraoxide are broken down, and therefore corrosion progression picks up. So with the provision of enough oxygen and water, the reinforced bar can corrode, and that is the mechanism of corrosion. The corrosion products are quite expensive. So once corrosion picks up, there is expected products that undergo volume change, and the literature says that the expansion, depending on the product, as you can see on that table, we have iron hydroxide, we have iron tetrahydroxide, and with the comparison with the iron, the volume expansion is estimated to be over 4 times to 6 times, depending on the oxide. And therefore, on the production of these products, there is expected expansion of the concrete mortar. In this case, therefore, we have the spalling and the maybe breaking of structures. It is estimated that 3.4% of global GDP is spent yearly to prevent, mitigate, and repair civil infrastructure damage due to chloride-induced corrosion. As you can see, it has been determined that the surface life of corrosion affecting reinforced concrete structures is as shown, that level of deterioration starts from the initiation, where the chlorine penetrates. Once the critical point, which is estimated to be 0.6 theoretically, propagation or pace picks up, and therefore the participation of steel takes course, and therefore in the section B there is formation of cracks and spelling of concrete cover with the time. As OCRUS 2002 did a qualitative guide for assessing the severity of corrosion structure. The corrosion rates of greater than 10 microampere per centimeter was high. 1.0 to 10 was moderate. 0.2 to 1 was low. Less than 0.2 was passive, and therefore at greater than 10 we now in this case, therefore, there is need for an alternative binder, and internationally there is a continued research on a new material, the alkali activated material, which is an alumina silicate binder formed by alkaline application of solid alumina and silica containing precursor materials with properties comparable to those of traditional cement binder at or slightly above room temperature. There are two mechanisms of alkali activation. One is when we use mainly silicate and calcium material mixed with a low to mild alkali. This is the method that I'm using. The alkali I'm using is sodium sulfate, which is the alkali. We have other alkali like sodium hydroxide, potassium hydroxide, sodium silicate, but I decided to use sodium sulfate because most of the research is basically centered on the highly active, the highly alkaline solution, the sodium and the rest. So the other one is when we use the primarily silicate aluminate, and in this case we form geopolymer. So I'll prepare the alkali activated using the milled alkali activator, sodium sulfate. So the material that I'm using is coconut shell that I calcine. I've picked the and then I have used waste from bricks. In this case, I'm trying to utilize the waste in a coastal region. The main product, the main crop is the coconut, and therefore we have a lot of waste left idle in pits and even in some of the towns. Therefore, I'm using the waste to come up with because from literature, these two materials have been found to be to have high percentage of silica, alumina, iron, which is a requirement of pozzolana. And from the research, as you cut the silica, alumina, iron, and the clay bricks from the site that I picked was researched, and the percentage was above 70, which is the requirement in East Africa standards. So this pozzolana material on the reaction, it is expected that there is formation of calcium alumina hydroxide and calcium silicate hydroxide, which is a gel that offers either increases the compressive strength or fills the pores in the matrix. Remember, pozzolanic reaction, and therefore we expect the pozzolana reaction to peak later after the hydration of OPC has peaked. So the pozzolana reaction basically suggests that on pozzolana reacting, it fills the pores, so that hinders entry of ions into the reinforced bar. At the same time, this pozzolana is able to react with the calcium chloride, leading to formation of free del sol, which also fills the pores, and therefore the entry of ions is also limited. There is also a formation of intrigites, especially with the alkali solution that I'm using, which is sodium sulfate. The sulfate part is able to react with calcium hydroxide. That calcium hydroxide sulfate reacts with the base, reacts with the calcium calcium aluminate to form the intrigite. Intrigite is also a crystal, and therefore is able to offer either increase the compressive strength or fill the pores in the mortar matrix. Sulfate ions raises the pH of pore water, as you can see. There is production of hydroxide. On dilution of sulfate, there is production of hydroxide. That increases the pH, therefore reduces the corrosion progress. So if more OH is produced, the pH also will increase, and therefore will protect or will protect the passivation layer. Now, there is sincere need for durable concrete to evade high cost of repair, damage, and in some cases death, as you can see on that diagram. There have been several cases that over 50 cases have been reported from back 2020. Over 50 cases have been reported of houses collapsing, and one of the factor could be because of the corrosion of reinforced bars. So there is need for strong concrete. Alkali activated cement is a greener material, similar or better, having similar or better durability properties compared to conventional cement. So that's why I'm coming up with this alkali activated cement. We are also utilizing the waste, and therefore there is need. Coconut shell are in abundance, as you can see globally. I wish to determine the suitability of coconut shell and calcined clay brick waste for use in preparing alkali activated cement. Specific objective is mineralogical, chemical composition, the activity of coconut shell ash, clay brick waste, samples from selected region within Kenya, that is in eastern part of Kenya, in Kibwezi in particular. Effect of different concentration of selected chemical activator on COV, OPC, and PPC. That is my study area. Those are the methods. Samples we have picked, just like I've said. Picked coconut from the coastal region, clay brick waste from eastern part, Kibwezi, Makueni County. Picking the clay, I ground it into heated coconut shell into ash using improvised kiln, as we are going to see. I carried out particle size distribution to determine the reactivity. I carried out compressive strength, water solubility, and corrosion resistance. This is the improvised kiln that I used. Remember, we don't expect complete burning because the heat is not controlled. Just like as you can see this formulation, this is the coconut shell ash with the black spots. So we expect unburnt carbon particles, the OPC and clay briquettes together with the sand, using East Africa standard in formulation. That is a compressive strength machine that I use to determine compressive strength. This is the impress current setup that I used to carry out simulated corrosion setup. This was before corrosion. This is after corrosion. The first image is, you can see it has undergone a lot of corrosion, followed by the second one. That was after 14 days. That was what was seen using the PD. So that's the setup. And one of the sample that I picked with a crack after 14 days, you can see the expansive products of corrosion and the harmful effect they have on these concrete structures. I carried out chemical analysis of the test samples with the coconut shell ash and clay brick, meeting the standards, East Africa standard of pozzolana, that is above 70, clay brickworks with above 90, while coconut shell above 70. So coconut shell ash and lower, silica, alumina, iron content. Basically, we can say coconut shell ash is less reactive because of less iron, silica, alumina. But then there is need for the learning tests, which I did. The cement that I used, the OPC and the PC, met the cement standards, though the composition meeting the standards. Average, I carried out pozzolaning tests, and I realized that the rate of consumption of calcium hydroxide, because I used conductometry, whereby I used solution of calcium hydroxide and reacted with the coconut shell ash and the clay brickworks, and I realized that coconut shell ash had a lower rate of consuming the calcium hydroxide, meaning that the reactive part, part of coconut shell was less than it was for clay brickworks. Remember, for pozzolanic materials, for them to be reactive, they need to be calcined, and literature shows that the calcining temperature to attain the reactive level, the amorphous state, is between 5 to around 800 or 9 for clay, while for organic material is usually between 4 to around 7 degrees. So the heating component likely met that level, and therefore we expect amorphous states in both cases. So clay bricks showed high reactivity, and therefore better pozzolana. I also carried out particle distribution, and therefore I realized most of the particles of clay brickworks were below 45 micrometer, which is a standard for cement, and therefore coconut shell ash was below 90. Could be possibly because of the unburned particles of carbon that gave bigger particles on the coconut shell ash. So we expect less reactivity on coconut shell as far as particle size is concerned, because reactivity is affected by the particle size. That is the formulation of my binders that I came up with, the 523 and the 541, whereby I kept
Festus, you have disappeared. Hello, Festus. Hello, Festus. Festus, you can hear us? No. Is there anybody close to Festus to tell him to log in again? He was almost completing his presentation.
fruitful discussions. And we are now ready to have our fifth keynote speaker from 11 to 11:40. Our fifth keynote speaker is Professor Rajeshwara Achur. Professor Achur comes to us from the University of Kafumbe in Shimoga, Karnataka, India. He is a professor of biochemistry at the Department of Biochemistry. Professor Achur holds a PhD in biochemistry from Penn State University College of Health and an MSc in organic chemistry from the University of Mysore, India. He is currently serving as an adjunct lecturer at NITTE, Dean University, India, and also an adjunct lecturer at Penn State University, USA. He has over 20 years experience in research, teaching, and mentorship in academia, and has published over 100 research papers, participated in over 50 academic conferences, and mentored 22 PhD students in his academic career. He has received various awards and grants, and most recently, he received the JSPS Innovational Fellowship long-term to work with Professor Richard Suleton from Ehime University, Japan. So we're going to welcome Professor Achur to take us through his keynote speech entitled The Current Scenario of Malaria Burden and Future Prospects of Eradication. Welcome, Professor Achur.
Thank you very much for the nice introduction. I am very, first of all, good morning to all of you. I'm very thankful to the University of Eldoret and the authorities, the Vice Chancellor, Professor Teresa Akenga, and the Department of the Biochemistry, headed by Dr. Enos Bambu, the management of the University of Eldoret, and of course, Kipto Jeffrey, who was one of my favorite PhD students who did PhD with me, and then he's solely responsible for my participation in this conference. And then I'm very happy to be here and then give some aspects of the malaria which I have been working for several years, and hopefully that will help the audience. So I would like to now share the screen with my slides. So as you're aware, this is the topic that I'm going to speak to, the current the scenario of malaria burden and the future prospects of the eradication at this chemical sciences conference. And as I mentioned, I'm very happy to present some of the aspects of this particular topic. So going through this the presentation, this is one of the slides which will, where everybody would like to be in this world where we are safe, we are not bothered by any type of microorganisms, and then we are all happy. But in reality, that is not the case. As you know, we have been in this midst of all these microorganisms, and then which causes a lot of various types of diseases. Every day we are encountering with these disease-causing microorganisms. And of course, in addition to this, we do have some other lifestyle diseases and the genetic disorders. So all those things together complicate our life. And then next slide tells you the burden, the disease burden, what we see, the number of, the deaths, and then the problems we face because of various types of diseases. And of course, at the top of this list, as you can see, there are mostly the cardiovascular diseases, the cancer, and the respiratory diseases, and all those diseases which really takes a lot of lives. And then, as you can see here, the malaria is somewhere in the middle, maybe in the 16th or 17th place in terms of total deaths, the worldwide deaths. But coming to the the deaths, as you can see here, the malaria deaths, mostly it is in the African continent, and of course some of the even the regions of Asia, Southeast Asia are also highly prevalent in this disease. And the overall burden, as you can see here, the Africa, the contribution by the African nations is really more than 95%, whereas the rest of the world is only about the 5% in terms of the total deaths by the world, as well as that compared to the African region. Within the Africa, as you can see in this slide, there are several countries within Africa like Nigeria, the Congo, Uganda, and all those things, they contribute a lot. Whereas so many other countries, including Kenya and other countries, they do contribute to a very lesser extent, maybe 1% or even less than that. Nevertheless, the overall contribution is very much significant from the African region. And the other one of the aspect that is very critical here is the cause of death in children who are under the age of 5. So look at the worldwide deaths in the year 2019. Although the number of deaths are more due to the respiratory infections, neonatal deaths, and other diseases, but even look at the malaria. It was somewhere here in the middle. Now it came up. So that means the number of deaths in children is mainly due to malaria. And then one of the thing we have to look into the fact that all these malaria deaths mostly occur in the African region, and probably well spread out around the world. Whereas under the age of 5, the children mostly die due to malaria, mainly in the African region. So that is one of the reason why we have to look into this very seriously, because the child mortality is very high in the African region. As you can see here, most of the African region where child mortality is very high. And then coming to the burden of this, mostly it is Africa and some regions of Southeast Asia, where children are mostly highly vulnerable to death. And as you can see here in this slide, the death from malaria by age. So look at the death toll here. So the children under the 5 or until 10 to 15 years, most likely like two-thirds of all the deaths to malaria is in. That is the reason that again, all these deaths occur mostly in the African subcontinent. So this is really one of the very disturbing data, because it mostly affects the children. So that is the reason a lot of research is being carried out to lessen the burden, and then to find a cure, vaccine in the form of vaccine or in the form of anti-malarial drugs. So coming back to the malaria disease, as you know, it is one of the deadliest disease spread by the vector, that is the mosquito. So mosquito is the vector which spreads this disease. And of course, the mosquitoes are the deadliest kind of vectors which can transmit a range of diseases, like including malaria, yellow fever, dengue, and then other viral fevers. And we can name many of these diseases. And again, all these diseases mostly in the developing countries or underdeveloped countries. So the deaths due to the mosquito is really enormous in terms of these kind of diseases. So our focus today is not going to talk about all those diseases, but just we'll focus on the disease malaria, and then we'll see starting from the history. So how old this malaria? Probably nobody knows, because as long as the humans existed on this earth, probably this disease was there. As you can see, there are some medical writings in the Chinese books, where we can see even as early as 2700 BC, they explained, they told about some of the symptoms of a disease that probably by looking at the characteristics of those diseases, maybe that is nothing but malaria. So this history of this malaria is very long, but it was all not recorded. So coming to the recorded history of malaria. So this is probably from around from 1900s. As you can see here, the world initially all over the world, this was spread out kind of the disease, and then started slowly eradicated from certain regions. So over the years, there is the good news is the malaria map is shrinking. So the shrinking such that probably, as you can see here, if the efforts have been doing well, and then probably by end of like 2040, probably we will see the total eradication of malaria from this earth. Given that we should have a proper plan, and then we have to work towards in a coordinated manner for the elimination of this disease. So based on the facts available in 2016, because to eradicate such a deadly disease, really we need to have a very coordinated plan. And keeping that view, and we have seen a lot of developments happening over the years. There are so many countries, now more than 100 countries worldwide, they are free of malaria. So that means there is a good news. It is possible if you make a coordinated efforts from all the directions, the support of course, we have WHO, which is time and again, which is making a lot of policies, changes, and then it is partnering with various other organizations, the governments, so that this is one of the deadliest disease, how this disease can be controlled and finally eliminated. So as I mentioned, originally it was almost everywhere. Now this malaria map has been shrinking, and then there are positive news. As I said, every year, more and more countries are becoming malaria free. So at least, as you can see in the last one in June 2021, China, which is one of the, in terms of its area, is a big country. And then it has made very coordinated efforts. And then it is certified as malaria free in June 2021. So if everybody works together coordinatively, definitely any country can achieve this certification by WHO. So WHO, by looking into the statistics that is available in 2016, it made some kind of policy, so that, and it also created some kind of milestones that need to be achieved over the years, and that is called as global technical strategy for the elimination of malaria, and that is a vision for the world free of malaria. And in this towards this direction, they have set up various milestones for 2020, 2025, and then 2030, and then 40, so on and so forth. And then the good news is there was like, at least they were hoping by 2020, at least 10 countries should be free of malaria. That means malaria elimination should be there at least in 10 countries. And then they have been able to achieve this by 2020. 10 countries were found to be malaria free as compared to that of in 2015. So similarly, again, in 2025, the target is another 20 countries to be malaria free, and then by 2030, their aim is to make another 35 countries malaria free. Ultimately, as I mentioned, 2040, we should be able to see this whole entire world free of malaria. And of course, to just by putting this milestone is not going to happen. We should have all the coordinated effort from various directions. Like you should have a strong political will, should have strong strategic information that is already available, and then there should be leaders who will guide these things better, and then coordinated response from everybody. And all these things, if it is becomes very coordinated, definitely there will be a positive outcome, and then that should lead to a very high impact, the reduction in mortality and morbidity, and ultimately, as I mentioned, we should be able to see the world free of malaria by 2040. And to achieve this, as I told, it is a coordinated effort is very important, and then every country has to make its own plans, and then contribute towards the malaria-free world. For example, India, which has made its own plans, so that by according to its plans, probably by 2030, we should be able to see malaria-free India. So just likewise, like just our country, India, and then we have all these kind of plans from other nations in the world. So that ultimately they will end up in getting rid of malaria from this world. So keeping these plans from individual countries, again, the World Health Organization, it made another, created another, it selected some 25 countries that is for the elimination of malaria by 2025. So that is called as E2025 initiative, where there are about 25 countries supposed to be, hopefully, out of this 25, at least 20 countries should be free of malaria by 2025. So gradually, that is the goal of WHO. Every 5 years, they would like to add some countries, then work towards. So now the focus will be on these countries towards elimination of malaria. And as you can see here, there are not many countries from the African region, and the reason, why? Because it is highly prevalent in Africa compared to other regions of the world. So they will start with these countries, and then probably then target the African countries in the next phase for the elimination program. And coming back to some of the facts and figures about the malaria disease. As I told you, malaria is caused by the Plasmodium protozoan parasite, and it is estimated that in around 300 to 500 million people infected, with 2 to 3 million deaths annually worldwide. So again, there is another point I have to mention here is the number that is 2 to 3 million deaths, it may not be the true figure. That may be really a lot more than this, because so many deaths due to malaria are not really being recorded properly. And then because this is the death, this is the disease of the poor, and then the countries which really do not keep particular details about the deaths that is occurring due to malaria. And as I said, this could be even more than what that has been recorded here. And then again, the disease is endemic to more than 100 countries. And then, as I said, the fact that this affects mostly children and pregnant women is the one which really bothers everybody. And then then we need to do something to eradicate this disease. So it doesn't mean that the scientists are not working. They have been working for many years, but still not much with success. That is due to the reason that there is an increase in the resistance to drugs that is already being used for treating the malaria. And in addition to that, there is a lack of effective vaccine. So for treating any disease, as you know, we should have either a very effective drug or effective vaccine. But in the case of malaria, both are problematic. We do not have, of course, we have drugs to treat malaria, but I'll come to that fact that why these drugs are becoming useless, because there is a resistance. So the parasite is very intelligent, and then the drugs becoming useless over the years. And then another thing is there is not much coordinated effort to produce an effective vaccine. So that is the reason we are not able to reduce the deaths or the infections due to malaria. Coming to the type of the species, I already told you the Plasmodium is the one which is causing the human malaria. And then among these different species, we have P. falciparum, P. vivax, P. ovale, and then P. malariae. These are the good old species. And then recently we have another species, that is newer species, the P. knowlesi. So this is the newer species. So originally it used to infect only the monkeys. Now again, see how it is transformed itself. And they started infecting humans also. So this kind of new challenges are coming up for the malaria elimination or the control program, because as I said, these parasites are becoming very intelligent. They would like to evade all the efforts that are being made. And so this is one of the recent addition is the one more species started becoming infecting the humans. So nevertheless, among all these species, as it might be knowing, the Plasmodium falciparum is the one which is the deadliest, which causes almost more than 90% of all the infections, and even more than 90 to 95% of all the deaths that occur annually are mostly due to P. falciparum, and then the most are in the African children. So these are the really factors which is bothering the scientific community. And as I coming to some of the facts and figures of this P. falciparum, this is the most dangerous form of malaria, and it leads to the risk of developing cerebral malaria, renal failure, acute respiratory syndrome, and then severe anemia. So whenever there is an infection due to P. falciparum, the prompt treatment is essential. Otherwise, if it is not treated, and then that would really become the fatal. And of course, once the person is treated and cured, there is no risk of relapse. But again, another time you get infected. So that is about this P. falciparum. And then it also, there is no dormant liver stage of, form of this P. falciparum, which is, and of course, which is dormant stage is only seen in the case of Plasmodium vivax. So coming to the other species, vivax and then oval. So it is less likely to be life-threatening than P. falciparum. As I said, among all these 6 species, P. falciparum is the deadliest and which causes severe form of disease. And then symptoms can still be the dramatic. And now the scenario is whenever there are, as I mentioned, whether it is P. falciparum or P. vivax or P. oval, whatever it is, the scenario is whenever people get infected, that can cause either the mild or severe malaria. So mild is also called as uncomplicated malaria. And if it is not treated, then it leads to the severe or complicated malaria. So whenever there is an infection, it is very important that it is being treated in the early stage so that it will not move towards the severe malaria. As I mentioned, P. vivax supposed to be very mild kind of benign parasite causing malaria, but recently again we have bad news. The usually used to cause only uncomplicated or mild malaria, but recent data suggests that even P. vivax can also cause the severe malaria. So that is one of the again adaptations of this parasite that is changing its severity now. So the guy which was really mild now become really virulent and violent, and then it is going to cause the severe malaria. So all these, whether it is uncomplicated and severe malaria, what are the symptoms? So if it is uncomplicated malaria, the symptom is the fever, that is the basic symptom, and then of course, and any of the following like headache, the body ache, joint pain, feeling cold, shivering, and loss of appetite, and sometimes the abdominal pains, diarrhea, nausea, and then vomiting, the splenomegaly. And all these symptoms are due to the uncomplicated or the mild malaria. But when it becomes, if it is not treated properly, this will transform into severe or complicated malaria, and which is defined as the fever and any of the following, like impaired consciousness, anxiety, palpitation and sweating, the convulsions, and then the difficulty in breathing, vomiting, unable to feed, pale hands, tongue and inner parts of the eyelid, and generalized body weakness, and then dehydration, and jaundice, severe malnutrition, and then even dark urine or no urine. So these are all the symptoms which is characteristic of the severe malaria. Now, the question is why, what is the reason why it becomes severe and complicated malaria? So initially, as I mentioned, it will be like a mild form of malaria. If it is not treated, at that time, then it leads to the severe or complicated malaria. And what is the reason? The reason is being whenever, especially the P. falciparum infected red blood cells attacks, it becomes infected, they will go and then sequester or bind in vital organs. So in the body, we have so many vital organs. So whenever the P. falciparum attacks or infects the red blood cell becomes, it is modified, and then a lot of proteins will be expressed on the surface of red blood cell. And then these proteins go and then stick to the vital organs in the body. And that is the reason we see the complicated malaria. And the question is, why the sequestration? What is the reason why these infected red blood cells go and then bind? It's also called as sequestration in various vital organs of the body. The reason is we have lot of host receptors in the body. And then, for example, look at this here. This is the RBC. When this RBC is attacked by erythrocyte, is when infected by the parasite like P. falciparum, it makes a lot of changes on the surface of this RBC. Look at this here, knobs. It forms knobs, and then it expresses a lot of the proteins on the surface, and then a lot of the morphological changes occurs on the surface of RBCs, and that makes these RBCs sticky RBCs. So otherwise it is not sticky because of the expression of knobs and then proteins and then so many morphological modifications. This RBC now becomes sticky because it is infected with the Plasmodium falciparum. So this sticky RBCs go and then sticks. It will also become rosetting. That means the clumping takes place. Also, it goes to various blood capillaries in the body, and then look at this here. It all becomes a clump. It is called as the cytoaderase. So because of these modifications due to the infection by the parasite, this will go and then stick to the blood capillaries, and then it leads to the severe form of disease. So this is because of what is called as the host, the parasite interaction. As I mentioned, in the human body, we have a lot of host receptors. And of course, in the next slide, as I can show you, there are so many host receptors in the body, like CD36, ICAM1, VCAM1, P-selectin. There are so many host receptors in the body. And of course, these receptors are not for the purpose of helping the parasite, but these are all for other functions of the body. For example, we have so many like in brain, we have ICAM1, and then we have microvasculature, CD36, and then in various organs we have this capillary. So we have all these receptors in the vital organs, and then this parasite becomes, as I said, after they become infected with falciparum, that becomes a sticky parasite, and then the sticky RBC, and then look at this, it goes and sticks all over the blood capillaries. It goes and then it sticks, it goes to the brain, the microvasculature, and then all these things leads to the complicated malaria. And then, as I said, if it is not treated properly, it will ultimately become fatal and lead to death. And in here, I would like to focus on one of the receptors that we have worked, during my association with Professor Chennaigoda at the Penn State University in the USA. So this is one of the important the receptor that is we characterized, and then that is present in the placenta. So just like any other organ, the placenta is one of the organ. When women get the pregnant, they will have this the placenta, and then placenta expresses a lot of this the chondroitin 4-sulfate, and then this is one of the, as I said, this is one of the host receptor. Just like other receptors, we have this chondroitin 4-sulfate receptor that is expressed in the placenta. And of course, again, this is nothing to do with for the purpose of parasite adherence. It has its own role in the placenta in the development of the fetus. But however, the infected RBCs, they see this receptor in the placenta and then start going, then sticking there, and then leading to what is called as the pregnancy malaria. So pregnancy malaria is one of the very complicated conditions when women get pregnant during the pregnancy period. When if it is infected with the malaria, then these malarial parasite infected RBCs go and stick to the placenta, and leading to the pregnancy malaria. And then we really work a lot on this, on discovering the molecular basis of parasite sequestration during P. falciparum. I'm not going to present any of these the data. This itself is a big study we did for over 5 to 10 years, we worked on this aspect of the parasite sequestration during P. falciparum. And during this, the pregnancy malaria, what is going to happen is it increases the risk of the maternal anemia, maternal death, miscarriage, the stillbirth, low birth weight, and then we have the intrauterine growth retardation as well as preterm delivery. So all these complications that they are possible during the pregnancy malaria, and because of this, we wanted to work on this project to find out the receptor as well as the ligand, which is responsible for causing the pregnancy malaria. And then we know the parasite, as I already mentioned, the parasite goes and accumulates in the placenta. And then we have, as I mentioned, the placenta, we have chondroitin 4-sulfate receptors. And then worldwide, this is a very severe problem, the pregnancy malaria. More than 50 million pregnant women exposed to malaria each year. And then out of that, about 3.5 million pregnant women infected, and only affects the primigravid, that is during first pregnancy. And another thing is very critical here is, again, this is mostly prevalent in Africa, African subcontinent, because that's where we know high incidence of P. falciparum, and the P. falciparum is the one which is mostly responsible for pregnancy malaria. So as I told you, we looked into the receptor as well as ligand, and then we characterized this chondroitin 4-sulfate receptor on the surface of the placenta, and then we also looked into the ligand that is called as the WAR2CSA. It is a protein that is expressed on the surface of parasite-infected red blood cells. So during the pregnancy, the placenta has a lot of the chondroitin 4-sulfate receptors, and then this parasite-infected RBCs goes and then binds and sticks to all these surface of the placenta, and then, as I mentioned in the previous slide, leads to a lot of complications. Ultimately, it may be leading to death in the mother as well as the fetus, as well as severe complications. Anyway, I am not going to details of this. This is about the protein, as I mentioned, that is responsible for, that is expressed on the surface of the RBCs, which is infected with the P. falciparum. This is the domain structure of the PFEMP1. And I'm not going to details of this, but it has got various domains, and then that is implicated in binding of these parasite-infected RBCs into the placenta. So this is also again another slide where this is the protein that is expressed during pregnancy malaria by this parasite is called as WAR2CSA, and then which is one of the, it belongs to the family of what is called as P. falciparum erythrocyte membrane protein 1. So this WAR2CSA is very much critical, which is involved in binding of the parasite-infected RBCs into the placenta. So overall, just the gist of this whole study is we were able to look into the cause and effect of during infection during pregnancy. So the pregnancy, during pregnancy malaria, as I mentioned, the parasite-infected red blood cells go and sticks into the placenta. And which is the receptor? Receptor is the chondroitin 4-sulfate. That is a glycosaminoglycan that is there on the surface of the placenta, whereas the ligand is P. falciparum erythrocyte membrane protein 1, that is also called as WAR2CSA. This is expressed on the surface of infected RBCs. So the question is why we need to know all these things, because as I mentioned, we need to find a way to cure this pregnancy malaria also. For that, the characterizing both the receptor and the ligand was very critical, because the receptor, which is chondroitin 4-sulfate, now we know that this receptor, we can use the mimetics of the chondroitin 4-sulfate as a drug against pregnancy malaria. And then we know we have characterized this WAR2C as a protein. This can be used for the development of vaccine. So for the development of effective vaccine as well as effective the therapeutic drug, the characterization of both the receptor and the ligand was very important. And then this has been done. And then the further work is going on towards the development of vaccine based on WAR2CSA for pregnancy malaria as well as the therapeutics, which is based on the contact enforcer analogs. So the main important now coming to the malaria control strategies. There are, as I mentioned earlier also, we need coordinated effort from various angles. The main strategies to control malaria globally are definitely it's to start with vector control and then use of long-lasting insecticide treated bed nets, and then very early and then prompt and then the diagnosis of the disease, and then immediate treatment with ACTs. I will come to this ACTs later. And then we also need to use proper chemo prevention methods in pregnant women and young children so that we can prevent the mortality rate. So in addition to these things, this is not just enough. We need to eradicate malaria only through the discovery of an effective vaccine as well as the anti-malarials. So the anti-malarial drugs and the vaccines are very important, very key towards the malaria eradication effectively. So we'll talk a little bit about these two aspects, the vaccine as well as the anti-malarial drugs. First of all, this is the life cycle of the malaria parasite. As you know, there are 3 stages. And I'm not going to details of this life cycle, but essentially there are 3 stages. One is inside the mosquito. This is called a sexual stage. And then we have 2 more stages in the human host. The first one is called as pre-erythrocytic stage, that is in the liver, that is called liver stage. And in the blood stage is the blood stage of the life cycle. And then all these three stages have been explored for the development of effective vaccine. And why these 3 stages have been explored? Because each stage has its own advantages. The development of pre-erythrocyte stage or liver stage is aimed to is very important to protect against early stage of malaria infection. And then if it is a blood stage vaccine, aim to reduce the severity of the disease. And in the third stage, that is transmission blocking vaccines, are intended to provide, prevent the spreading of malaria to new hosts. So the scientists have worked into all these 3 different types of vaccines. So I will come to that. What is the outcome of these the vaccines? Currently the status what we have is only one vaccine, that is RTSS vaccine is the one. This is the first one. Currently only the malaria vaccine is recommended by WHO. So apart from this, there are other vaccines that are in the process of development, like 2 vaccine candidates which are in the late stage clinical evaluation. They are there. And also we have additional candidates which is targeting the malaria life cycle stages that include blood stage candidates and a vaccine candidate targeting the sexual stage antigens to prevent malaria to the vaccine human to mosquito transmission. So all these different stages of vaccine are being tried, being worked out, and of course this all should be based on the guidelines of the WHO on the quality, safety, and efficacy of these vaccines. Apart from these things, you're all aware of the fact that there are recent developments, especially in case of the COVID, as you see, new types of vaccine that is called as mRNA vaccine that is being tried out. So, those kind of strategies are also being, new technology using mRNA as well as DNA-based vaccines are also being tried um, for malaria. And then they'll be using new adjuvants, and then they're also using other like virus-like particles for the delivery of this vaccine. And then the nanotechnology based based vaccines that are also being tried. So all these things are, various efforts are being made towards development of a vaccine. Although this vaccine is there, and but this is not really very effective. That is the one thing which we should and accept it. Although the vaccine has been recommended by WHO, and in total since 2000, there are about 10 different vaccines are being tried, being developed, and then there are so many the clinical trials that have taken place until now. So, and as I said, among all these vaccines, except this RTS vaccine, all other vaccines are really not going to protect really to the great extent. So, among all these vaccines, currently this one is in use, that also being tried now, and then there are other vaccines which should come in due course. So, as you know, for the development of vaccine, again, we have to use a lot of the antigens, and then whether it is the transmission blocking vaccines or anti-infection vaccines, as well as blood stage vaccines, there are so many proteins that have been used in various types of vaccines like PFS25, so many other proteins in the transmission blocking vaccines, and in the anti-infection vaccines. In the there is the liver stage. We have, this is the subunit vaccine, the RTSS vaccine, that is the liver stage vaccine, and then other types of vaccines, they are also being tried. And then the blood stage, we have other antigens that are being tried. So all these, the antigens, for example, look at this here. This is what I was mentioning earlier. During the placental malaria, we know this Vato-CSA being expressed, and then this Vato-CSA being tried for making a vaccine against the placental malaria. So this is the kind of research going on in the development of vaccines by targeting different stages. Nevertheless, we have high ambitions to make sure we will have a very effective vaccine, but in reality, it is not so. Although this is, as of now, this RTSS vaccine is the one which is highly efficacious, but this is not 100% effective. So the efficacy is lot less than what expected. And then, as I said, the results that are not really highly encouraging, but still there is something which is better than nothing. So we have a vaccine, although vaccine is not really that much effective, but definitely the scientific community can work further on this vaccine and then make it more effective. And they also aim to license another vaccine by 2025, the second generation, the vaccine that has the efficacy of at least the 80% against clinical disease. So that is what we are hoping for. And then the question is, of course, as I said, this is one of the latest data news that even world's first malaria vaccine is making inroads in Western Kenya. So this is being tried in even Kenya also. Very last month, we have this news where this vaccine is being employed in even Kenya also. So all over the world, this is being employed, being used. And then the question is, as I mentioned, why people are struggling to make effective vaccine? Why vaccines are very difficult to make in the case of the malaria? So the reason, there are very evident. The parasite, there is no effective vaccine against malaria because the parasite has evolved a series of strategies. So this is just like a cat and mouse game. It tries to confuse, hide, misdirect human immune system. So it is, the human system is not able to understand the strategy of this parasite. So it is confusing, it is hiding, it is making its own proteins, the different point of its development. And then, as I said, there are different stages where it makes different proteins, and then, and also it keeps on changing its protein. Just like we change our dress every day, even the parasite changes the surface proteins every now and then, and that means that makes the system very difficult. At least immune system as well as the development of vaccine is becoming very difficult, and that is the reason they are going for a cocktail of vaccine so that at least it will be to some extent effective. So all these things making it difficult. So that is the reason there is also the focus back on anti-malaria drugs. So we know vaccine is the ultimate, but if it is vaccine is not able to have any 100% efficacy, then also we need to go back to the anti-malaria drugs also. So the focus is both on the vaccine development as well as the anti-malaria drugs development. So coming to the anti-malaria drug, now the current focus is drugs based on the origin, the plant source, and this is one of the results we already know. There are so many plant-based drugs that are in practice, that have been used, and then that have been used to treat various diseases like cancer, hypertension, neurodegenerative diseases, infection diseases. In the latest, there are so many newer plant-based drugs have been developed or discovered, and then for Alzheimer's, malaria, and then there are various other diseases. So there is a hope that this plant source should serve as a novel source of the new anti-malarials. So this the development of the drug discovery from medicinal plants involves really a multi-pronged approach that includes the use of limited knowledge by traditional medicinal practitioners, botanists, medicinal chemists, the pharmacologists, and then molecular biologists. All these experts should sit together and then try to develop a novel anti-malarial drug. So there are, in the literature, we can see, if you go to the literature, this is just a few examples I am putting here. There in the literature, there are so many compounds that have been implicated in the for treating the malaria. And then this list is really big, but I'm just putting few of these things. So just like this, there are so many plant-based drugs have been implicated to treat malaria. Again, this is the target. I'm not really going to details of this, but there are on the surface of the parasite, we can see there are various targets. All these targets mostly used for the development of the drugs. So ultimately, the aim of these drugs are just like they want to prevent the parasite proliferating. So there are so many inhibitors. So all these inhibitors are trying to make sure that the parasite cycle doesn't go further. So it will stop somewhere, and then this is going to die. So that's why there are various inhibitors targeting various the cycles, various stages on this the parasite have been targeted, and this traditionally, we know what happens if you want to isolate a drug from the plant. You should select the plant and then do the routine things, and then sequential extraction, purifications, and then we'll end up with so many fractions, hundreds of compounds, even maybe more than 100, 200 compounds at one time when you extract. And then very tedious. You have to take out all those things and then try to separate and then identify all these lead molecules. And it is really cumbersome. It takes really long time. But now we have these modern methods where we have these in silico methods, drug discovery involves the chemoinformatics and bioinformatics technology, which really made these things much more simple. And then where we have, now be using various other advanced techniques, and then we for the identification, screening, and optimization of it, and then we know how to increase the affinity, the selectivity, the efficacy, the metabolic stability, and then oral bioavailability. So these are some of the strategies that are being used now. Starting from the original molecule from the plant, these are some of the strategies we use to make it more effective. So that is the modern drug discovery methods. And in this direction, finally, it will lead to reduce the potential side effects. And then we have high throughput screen and so many other methods we follow in order to develop a plant-based drug. So in all these plant-based drugs, they've identified some of the potential, the plant secondary metabolites, such as alkaloids, then flavonoids and chalcones, the terpenes, the terpenoids. So these are all the groups that are responsible for its activity. And also, this is nowadays being employed by what is called as reverse pharmacology. So this is the technique we use nowadays to increase the speed of the drug discovery by what is called as reverse pharmacology. If you are aware of the normal pharmacology, and then we know what is reverse pharmacology. So to define this, this is usually the normal pharmacology is from bench to bedside. That means you isolate a drug molecule in the laboratory and then try to identify the molecule which is for the treatment, and then take it to the clinical like trials from the animals, and then finally to the human trials. So that is the normal pharmacology. Do the basic research and then take it to the clinical research, and then if it is effective, then it is as a drug. So now, as I said, this is the normal pharmacology. You in the laboratory, you isolate and then identify the hits, lead compound, and then do some of the mice experiments, and then finally, if it is very effective, and then go into the inject to the patient. So that is from bench side to bedside. But now what we are talking about is the reverse pharmacology. So that is from bedside to bench. So what is this the reverse pharmacology? And the example. So the reverse pharmacology is the one which is based on the fact that there are so many traditional practitioners. They have been using various plant extracts for the treatment of various diseases. So you have to identify those molecules, those extracts, and then we know for sure this has been used for many, many years, thousands of years by the traditional practitioners, especially in Africa as well as in India and China. All these countries, they have been using various plant extracts for the treatment of various diseases. So the reverse pharmacology is focusing on this. You take these already known plant extracts and then go backwards. That is called as reverse pharmacology. So there is a success story. We know already the quinine from the bark of the cinchona tree, which is the first anti-malarial compound, which was used, and then which was isolated in 1800s, and then it has been used for many, many years to treat malaria. So as I said, the conventional pharmacology is the one where you isolate a molecule from the laboratory, and then do some clinical trial in the mice, and then finally in the human trial. Whereas the reverse pharmacology, already we know that some of the drugs which is being used for treatment, and then go backwards and then identify a molecule, or you modify a molecule or try to do some of the modification, and then do the reverse pharmacology. So, hello, 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 hello. Are you hearing me?
Continue.
Okay, how much time I have? Another 10 minutes? So that is what, as I said, this is the regular forward pharmacology, and then we are looking towards the reverse pharmacology, where the clinical the data, what we know, can be used to modify a molecule, and then in the laboratory, and then make it more effective. So this is, as I mentioned, the classical pharmacology is the one which really takes a lot of time, very expensive, time consuming, and then most of the time it will become very inefficient. Whereas the reverse pharmacology is the one which is also called as bedside to bedside, is a research approach that based on traditional knowledge. Already we know the traditional healers, they have been using so many extracts for the treatment of various diseases, and use that knowledge and then work towards backwards, and then try to modify the compound, and then so that it increase the efficacy, reduce the toxicity, all those things can be done. So this is called as reverse pharmacology. Again, it is a multidisciplinary approach based on the traditional knowledge, experimental observations, and clinical the experiments, all those things. So usually the normal pharmacology is take about 8 to 10 years for a drug to come to the market, whereas reverse pharmacology is mostly, it reduces at least 50% of the time drug to the market is about in 4 to 5 years. So that's why even in the development of anti-malarials, reverse pharmacology has been used. And then, after the quinine, the other anti-malarial drug from plant origin is nothing but already be very effective, that is artemisinin. And nowadays, the WHO is recommending only the artemisinin for the treatment of malaria. So especially it is in the form of what is called as ACTs, that means artemisinin-based combination therapy. That means if you use one type of drug, then there is a chance that the parasite develops resistance for the drug. So that's why the WHO is recommending the use of the combination therapies, where if it is uncomplicated malaria, there are so many different types of ACTs that are being used. It depends upon the type of infection and the region. So there is WHO website, all details have been given. So mostly these are the different combinations of ACTs that is being used. If it is for the treatment of uncomplicated malaria as well as the severe malaria, this only artesunate being tried. So these are all the some of the data which they use the original artemisinin and try to develop some of the derivatives of artemisinin by using reverse pharmacology, and we have so many derivatives of this artemisinin, and then this is the original artemisinin, and then from this original artemisinin they develop different derivatives by using reverse pharmacology, because they know this is the original drug molecule, and then they modified this drug so that these are all the, again, anti-malarials. They are more effective than artemisinin because there are some kind of modifications, so which is making the drug more effective. So this is again, this slide also you can see the artemisinin derivatives that are synthetic by using reverse pharmacology. This is the original artemisinin. They did modifications, group modifications, and then they made so many other derivatives. So ultimately, there are so many combinations, as I said, over the years that have been developed, currently developed from 1985 onwards. They have been various combinations being developed. And then very recently, there are newer drugs also being tried. And this WHO is making all the efforts towards making the new combination. And then there are so many research laboratories working on that. For example, this is one of the paper, as you can see, they have worked on the development of the discovery of a lot of newer anti-malarials. This is published very recently. Then there is another group in University of Georgia. They are also screening thousands of the plants. I think there are about 17,000 plants they have screened in order to find a effective anti-malarial. So nowadays the hope is for newer anti-malarials only from the plant source, and that is why the scientists are working on that. And ultimately, the aim is the control of the malaria burden. And the current interventions include the drugs, the treatment or prevention, and the insecticide, spraying, the larvicide, for several current regular interventions. Other than that, we also we have the environmental and behavioral modifications also. In addition to that, the future we'll have definitely we'll have to look for vaccine, very effective vaccine, and then the genetic modification of vectors. In addition to that, as I mentioned, the newer anti-malarials, because whatever the anti-malarials we have, probably the parasite will develop resistance. So we constantly need to work on the newer anti-malarials. So ultimately, the goal of the scientific community is malaria no more. So that's what we hope to achieve by 2040. And then, of course, these are the basic preventive measures. It is called as ABCD, the awareness, be aware of the risk of the malaria, and then try to avoid the bite with the mosquitoes, and then wherever possible take the chemoprophylaxis, that is anti-malarial drugs, and then finally this diagnosis. So immediately if there is some kind of symptoms, seek for immediate diagnosis, and then early treatment that will really is curable. And that is the reason, as I said, if its treatment is taken early, it will not go to the severe form of disease. So that's it. And then if you can do that effectively, definitely it is nothing but it is kind of our winning the war against the deadly, the vector, and then we can make sure that our world is free of malaria. So thank you very much for your patient hearing.
Thank you so much. Thank you so much, Professor Achur, for the elaborate and insightful.
So if there are any questions.
Thank you so much, Professor Achur, for
Hello.
the elaborate presentation. We have learned a lot about the current status and the future prospects of eradicating this deadly bug. And I'll open the floor for questions, comments, or observations for Professor Achur. You can raise your hand, you can speak up, you can drop your question on the chat, and Prof should be able to address that. Questions for Professor Achur? Okay, while the members are thinking of the questions, I have one basic question. In my rural home, I have seen my neighbors give children artemisinin leaves to be taken with beverages. How effective is that natural approach?
I'm not able to hear. Can you please be louder a little bit?
My question is, I have seen people utilize artemisinin in leaves,
Using?
but using artemisinin in leaves taken
Okay.
with beverages.
Yeah. Okay.
How effective is that?
Yeah, that is what I mentioned. So that we need to follow the recommendation of WHO. If you use irrationally these kind of things, then it lead to the drug resistance. If you use just artemisinin itself, then it may end up with the drug resistance. Of course, it can cure now, but if you are not using properly without the recommendations of the WHO as it is recommended, single drug using always is risky nowadays because it lead to the parasite develops drug resistance and then it becomes finally useless because we don't have any other alternative drug. So if there are alternative drugs, then it's okay, but there are very few drugs that are effective against malaria. So it is always better we use the drug as per the recommendations of WHO. Mostly, as I mentioned, it all should be combination therapies. It is 2 or more drugs together. Then there is very less chance of development of the drug resistance.
Great, thank you. There's a question on the chat. Let me just read it aloud. A member is appreciating the informative presentation.
Okay, thank you.
And presents 2 questions. What is your view regarding selective adherence of VA2-CSA to CSA during malaria in pregnancy and not other receptors? And the second part of the question is, what's the role of the other receptors during pregnancy?
As I mentioned, so during pregnancy, the parasite adjusts itself and then it expresses this VA2-CSA protein that specifically that is responsible for binding to the placenta. So otherwise, in regular non-pregnant women, there is no the placenta. So that means there is no binding. Whereas when the women become pregnant, they will express the placental receptors. As I said, it is called as contractile phospholipid receptors. Whenever this particular infected RBCs sees this contractile phospholipid receptors, it tries to express a protein which is specific to bind to the C4S, that is called as VA2-CSA. And then the other proteins are not at all involved in pregnancy malaria. So just VA2-CSA is involved, because that is the only one which is involved in binding to the placenta through the receptors C4S.
Okay, thank you. Another question. A participant is appreciating your wonderful presentation and poses a question. If the results on the vaccine were discouraging.
So any other question?
If the results of the vaccine were discouraging, why was it considered or approved by WHO?
Which one?
If the results on the
Hello?
vaccine were discouraging, why was it considered or approved by WHO?
Which one, madam? Hello?
I'll repeat the question.
Yeah, please.
If the results on the vaccine were discouraging, why was it considered or approved by WHO initially?
Yes. It is not totally discouraging. So I should say it is encouraging only, because till now we didn't have any vaccine to this effect. So it was totally used. We had all other vaccines. It was really totally failure. But currently, at least we have some vaccine which is at least 50% active. So we need to have vaccine. That is very critical. When you want to achieve the malaria eradication by 2040, we should have a vaccine. At least this is the starting step. Once we have one vaccine which at least 50% efficacy, and then we can improve on that. And then that is the first step we have to take. So that is the reason. As of now, as I said, this is the best vaccine we have, that we have to use it, so that we can prevent the the deaths as well as the severe malaria. So that is very critical, especially in pregnant women as well as in children. We need to protect them, and then we need to have at least some kind of protection. Even as you know, in the case of the COVID vaccine, whatever we know, there are still debates that it may not be very effective, right? So that is I said we have to start somewhere, and then we have one vaccine which is much better than all other vaccines which we tried earlier. So that's why the WHO is recommending this, and then we have to move forward and then try to improve on this vaccine and then get better vaccine in future days.
Thank you. Great. One more question along the line of vaccines. There is ongoing research to develop malaria vaccine, and a member is interested to know how far that has gone.
There are various clinical trials are going on. Probably, as I mentioned, in another 2025, we'll have another new lineup, another 2 more vaccines are going to come. They're all undergoing the clinical trials, and probably, hopefully, there will be better vaccines compared to the current vaccine. So this the vaccine research is heavily going on in terms of the malaria eradication. So we have a lot of groups working on the vaccine, and then they are working on the even different cocktail of the antigens, and then hopefully we'll have some very good vaccine in coming 2-3 years.
Okay, thank you. One more question on the chat. A member is appreciative of the informative presentation and poses a question.
Okay, thank you.
Why was DDT used to eradicate mosquitoes in developed countries, but its use was later banned in developing countries, especially in Africa?
We use irrationally DDT, and then that led to a lot of other consequences. So DDT has its own deleterious effect on the human health. So that is also very critical. And in some countries, we use the DDT so much, and there are data showing that even the breast milk, mother's breast milk contain a lot of DDT. So that kind of irrational use has been found, and then DDT is very dangerous to humans also. So that is the reason they are not encouraging the use of DDT, because that is giving another type of problem. So we know we want to kill the mosquitoes, but that is also very dangerous to humans also.
Sorry about that. Now, I was following your slides, and I noticed that in the schematic that you presented on the progression of infection in the host cell, between cycloadherence and agglutination, there's a possibility of inhibition of the progression of the bug. What has been done in that stage? Because it may inform the progress that is being made in reverse pharmacology.
Yeah, I mean, that is the thing, as I mentioned, in the case of, at least in the case of the pregnancy malaria, we know the receptors. So with the reverse pharmacology, we know there are so many drugs that can be used as inhibitors. So if you have an effective inhibitor, which is going to bind so that it will prevent the agglutination or the clumping, all those things can be avoided. So this is the small molecule drugs, which are inhibitors, especially there are various target inhibitors are being tried. And then if the inhibitor goes and binds, and then definitely they can avoid the clumping or the agglutination or site adherence, all those things.
Any more questions for Prof? Yeah, I see a question in the chat. A member is asking, is India looking on options of adoption of genetic engineering mosquitoes? That's
Yeah, that
interesting.
is another aspect that is being entirely a different approach. So there are like pros and cons. There are some groups they advocate use of the genetically modified mosquitoes, but there are other groups which they oppose the genetic manipulation. So this is one thing which is really controversial. And then in the laboratory scale, of course, they have made these genetically modified mosquitoes, but we don't know because there are so many ethical considerations here. Um, the mosquitoes are there just not to spread malaria disease. There are the ecological balance has to be maintained, right? So this is the whole all these species on the earth. It has one or the other role to play in the whole the balance of the ecological balance, maintain the ecological balance. So that is one thing which is really controversial, whether it is uh, beneficial or we don't know what is going to be the long-term effect if you use this genetically modified mosquitoes. So of course it looks very promising, but still there are pros and cons on this aspect.
Thank you so much. Any other questions, comments, or observations? Okay, there's one more question that has just come in. Thank you so much, Prof. Apart from strategies by parasites to confuse, hide, and misdirect human immune system, is there another challenge in vaccine development?
Yeah, vaccine development. Yeah, that is one thing. That is the one of the main reasons in there is challenge for vaccine development. Otherwise, the regular challenges, just like we know the vaccines, the adjuvant use of very good adjuvant, and then the life of the antigens. So all those things are regular challenges. That is true with any other vaccine. So those challenges will always be there. But in addition to those challenges, in the case of malaria, the challenge is more prominent because, as I said, the parasites keeps on changing its the surface proteins and then making it very difficult. So that's why the scientists are working on the cocktail of vaccines. So hopefully that kind of vaccine will be very effective in future.
Thank you. That is interesting to know. We will all remain hopeful that that bit of research progresses fast because we are part of the countries affected by malaria. If there are no more questions or comments or observations for Prof, I want to most sincerely, on behalf of all the participants, appreciate the work you have presented to us. It's very rich, very informative, and inspiring as well. Thank you so much for taking your time to be with us. Thank you so much for ushering us in. You were in before we were all in. So thank you so much, Prof. We want to wish you the very best. Thank you.
Okay. Thank you very much, madam, for being part of this wonderful your effort in conducting this conference, virtual conference. And then thank you very much again, you, and then as well as again, once again, I thank to Kipto Jeffrey also for making me to part of this conference. Thank you.
While we were giving our parting shots, there's someone who's just sent in a question. Maybe we can give you 1 minute to respond.
Sure.
Okay. Thank you. You can read and maybe we can continue outside the conference to get the responses to that question.
Sure. Yeah.
So let's all applaud Professor Achur for the very good work he has done. Thank you so much, Prof.
Thank you. Thank you.
So thank you so much, members. We're going to take a health break. I know our time is fast spent. We are late by a few minutes, not actually a few minutes. It's quite a while since we were to stop. So we are going to take 15 minutes health, then convene again for our last keynote speech. 15 minutes should find us here. That should be around 11:40. Thank you so much and enjoy your break.
morning. My name is John Degwa, and I welcome you to the third day of the virtual Chemical Sciences Conference being held between 16th and 18th of March 2022 at the Department of Chemistry and Biochemistry, University of Eldoret. The theme of the conference is Trends and Innovations in Chemical Science for Sustainable Development. Now, we are in the main conference room, and we want to welcome Dr. Vivian Tuwei to give a presentation as a keynote address to the participants. Now, Dr. Tuwei, Vivian Tuwei, is a lecturer of chemistry and molecular biosciences at the Department of Chemistry and Biochemistry. She is currently the coordinator of the biochemistry postgraduate program at the department. She holds a Bachelor of Science degree in biochemistry and chemistry, first class honors, from the University of Nairobi in 2005, and a Master of Science in 2007, and a PhD in 2010 from the University of Hawaii at Manoa, Hawaii, USA, in the molecular biosciences and bioengineering. Her PhD research on effects of fatty acids on albumin-mediated cholesterol efflux from endothelial cells and on the growth of hamster pancreatic beta cells was supported by the African Heart Association Predoctoral Fellowship. She previously worked as a lecturer of biochemistry. She previously worked as a lecturer of biochemistry. She has held leadership positions as head of Department of Biological Sciences at University of Kabianga, Kericho, Kenya in 2015, head of Department Chemistry and Biochemistry, University of Eldoret between 2019 and 2021. Dr. Tuwei has extensive teaching experience in biochemistry and molecular biology and continues to mentor and supervise undergraduate and postgraduate students on research in biochemistry. Her current research interest is on the molecular basis of metabolic diseases and role of nutrients and toxicants, particularly in diabetes mellitus, obesity, metabolic syndrome, cardiovascular diseases, and cancer. She has received various awards and grants, such as research grant, National Research Fund, from National Research Fund. She currently serves as an ad hoc reviewer for several journals and the University of Eldoret's annual grant proposals. She has externally examined several theses for University of Nairobi and Egerton University, Kenya, as well as being an international thesis examiner for University of Nairobi and Egerton University, Kenya, as well as being an internal thesis examiner for University of Eldoret. Now, Dr. Tuwei has several peer-reviewed journal publications, abstracts, and a book chapter, and she has participated in several academic conferences. She gives inspirational talks on career choices to the youth, among others. Her presentation today is entitled Potential Health Effects of Ingestion of Transformer mineral oil and she is going to educate us on that subject. Welcome, Dr. Tuei. I hope you can hear me. Dr. Tuei?
Yeah, thank you, Mr. Ndegwa. Can you hear me?
Yes, I can hear you.
Okay. Thank you, Mr. Ndegwa, for your elaborate introduction of me. It's a great honor today to be one of the keynote speakers in this conference. In fact, it's my first time ever being a keynote speaker in any conference. So indeed, it's a big honor. My presentation today is titled The Potential Health Effects of Ingestion of Transformer Mineral Oil. This is work that we did collaboratively together with my former student, Grace Otunga, and scholars from the School of Medicine, Moi University, Dr. Geoffrey Mayo, and Dr. Benson Macharia. For my presentation today, I'll follow this outline. I'll begin with a background, highlighting the research gap and studies justification, then proceed to the studies objectives, then get to the methodology, the results and discussion, conclusion and future studies, and I'll wrap up with the acknowledgements. So I'm beginning with the background. On this slide, and particularly on the right, is a picture of a transformer. This is a Kenya Power Lightning Company transformer. And what is usually found inside these transformers is, of course, a number of electrical features, but it also has an insulating oil, which we call the transformer mineral oil, or TMO. This oil is a clear liquid, and it has an odor of petroleum, and you'll find out why as I progress in this presentation. The oil is also very stable at high temperatures, and that's why it's used for insulation of these transformers and many other electrical devices. In Kenya, however, we have a number of cases of vandalism of these transformers, particularly the one you're seeing for KPLC, for obtaining the oil, the TMO oil, for cooking purposes. And in this slide, this just illustrates some of the cases that have been reported of this transformer vandalism that I've said. The first picture there, which you are seeing on the left, is actually a vandalized KPLC transformer in Thika Town, Kenya, which was actually featured by Al Jazeera. And the right picture sadly illustrates a man who was electrocuted when he was vandalizing, trying to get the oil from a transformer in Dandora, Nairobi. So these cases of transformer vandalism to get the oil has been reported, has been captured, and I've just illustrated a few examples. So why should we be really concerned about this vandalism of transformers to obtain the oil? The concern is arising because some of the commercial deep fried food vendors that we have in Kenya use the oil in preparation of the deep fried foods, particularly like our local chips or fries, frying fish, and even frying the local donuts that we call mandazi. So that's the concern. We are saying that we are getting the oil when we enjoy these deep fried foods from these vendors. Some of these vendors intentionally had the oil. And why they do use the TMO is because it's not easily oxidized, and I've said it's also very stable. So it can be used repeatedly during the deep frying process because it's a bit stable. And of course, because they get the oil from vandalism, the price could be quite really low. Because if they were to buy the edible oil softened and use it for the proper deep frying, it will be costly to them. So most of the vendors actually blend. They use the edible cooking oils that we have or fats, and they blend with the TMO to give it the stability so that they can keep on reusing it over and over again. So that's the concern that I'm bringing, that we are eating some of these foods, and in the process, we are getting the oil into our system. When we look at the sources and composition of this oil, we are calling it TMO. The primary source has been crude oil or petroleum. And that's why the order is, if you smell the oil, the odor will always have that crude oil smell or odor. But the
Recording in
other
progress.
But the other minor alternatives that are now coming up, but it's still very minor in the market. Examples are the siloxane-based synthetics, and also the carbon-7, carbon-8 fatty acid-based esters. And I think the drive is to get alternatives that have low flammability compared to TMO. When you look at the composition, the oil has a very complex mixture of hydrocarbons. They are generally classified as paraffinic or naphthenic-rich oils. And I'll say that the transformers, particularly the KPLC transformers that we have in the country, they mainly use the naphthenic-rich oils. Other components in this oil are the polycyclic aromatic hydrocarbons, and an example is benzoylpyrene, which, however, sadly has been classified as a carcinogen. It can cause cancer, and also it elicits other toxic effects. So again, highlighting the concern that we should have, that from ingesting TMO through the deep fried foods, which have been prepared by some of the vendors by mixing edible oils and the TMO, we could be getting some of these toxicants that are found in the complexity of the constituents of the transformer mineral oil. And just to highlight the same health concern, I'm just showing a snapshot of one of the review papers that we authored, and this is on the rising cancer incidence and role of evolving diet in Kenya. And to just highlight a few of the risk factors and contributing factors to cancer that we found out, and in relevance to this talk that I'm giving, is what I've highlighted at the third last line of the abstract. So one of them is the reuse of frying fats and oils. And these are the edible oils. So the point is, when edible oils or even fats are repeatedly eaten and used over time, which is a very common scenario with our commercial vendors doing deep frying, the oils, or in that process of eating the oils, there are some potential compounds which are produced. Most of them are the polycyclic aromatic hydrocarbons, some heterocyclic amines, which can be potentially be classified as carcinogens, and of course they can elicit other toxic effects. So this has been made worse. We are saying this is a contributing factor to cancer in Kenya, but I've said there are now commercial vendors, again, adding the TMO that has that potential also, so that they can even reuse it for a longer period. So I hope you're getting the point that it's really a problem, one arm of reusing edible oils, and this other problem where there's TMO with its own possible carcinogenic compounds, and now the long-term reuse of the oils in that process. And one last other factor that I just want to highlight is a close crude oil product, kerosene. The scenario in Kenya is that some of the high schools actually add kerosene to the local delicacy that is served to students in high schools called githeri, which is our local food made up of cooked beans and maize. So they had kerosene, and the thinking is that kerosene will lower the sex drive or even aggressiveness in adolescent girls and boys. So, which is not, of course, backed by any scientific data. Kerosene, again, it's a crude oil product with its own complexity in terms of structure and composition. So it can also be the contributors that we are having from the diet in Kenya. And that's why I'm just highlighting the role of these factors in the causation of cancers and to bring the concern that we have in this discussion. Now, as much as we think of vandalism of transformers to get the oil in Kenya, it might not be a Kenya problem alone. It could be really occurring in our neighboring African nations because we share a lot in common. But in this slide, I just want to show the concern also in the European nations. And this is a snapshot of minutes of a working group in of what an organization or regulatory group called the European Food Safety Authority. This is a snapshot of minutes of this working group on mineral oil hydrocarbons in food, mainly as contaminants. So their concern might just be much on contamination, which is not intentional, like the case in Kenya, but you can see the concern is on presence of mineral oil hydrocarbons, like from transformer mineral oil and other products in the food chain. So these engagements by this authority actually began in 2012, and it's ongoing. You can see they even held this meeting late last year, which is quite recent. And what they found out even from 2012 to date is that there is not much of enough toxicological data to guide regulatory bodies or even a scientific community for them to advise on how we need to assess some of these compounds in food or to give health guidelines regarding the same. So they've been encouraging the scientific community to do studies more so with all mixtures of these compounds containing the mineral oil hydrocarbons. So you can see that this is something that is of a concern also. It can be a global concern, and we are all together in this. So the question is, where are we exactly at the moment in terms of mainly the toxicological profile of the transformer mineral oil? Currently, there are still no studies that have been done, subacute or even chronic toxicity studies, mainly oral toxicity studies of this transformer mineral oil following consumption, like what I've highlighted from the cooking process, or even pure toxicological studies. So there's still that gap there. And this is happening despite what I've said. Many Kenyans are unknowingly ingesting the oil when they enjoy the deep fried foods from some of the vendors who have added up the TMO with the edible oils. So in our study, we therefore used a rat model to determine the potential subacute toxic effects of ingestion of TMO in this rat model as a way of trying to provide insightful information on the toxicological profile of TMO, which is lacking, as I've said. So more specifically, in our study, we did a subacute oral toxicity study using a Worcester albino rat that have indicated the picture down there. This is a laboratory rat, which is highly recommended for toxicological studies. And a subacute oral toxicity study takes 28 days. And we assessed at the end of this and in between, for some cases, the impact on the animal body weight as an indicator of some toxicological impact, and also the impact on blood parameters, mainly the whole blood parameters, and also on the serum parameters, which are indices of mainly the liver and the kidney function. We also assessed the liver tissues to see if there is any oxidative stress by assessing an oxidant called malone dihaldehyde. And that usually arises when there is lipid peroxidation in tissues or in cells, very common in the liver when it's undergoing oxidative stress. And lastly, we assessed the histology of mainly the liver, the kidney, and the small intestine to see if there were any histopathological changes. And more so because the liver is the main receiver of most of what we ingest, and it detoxifies, or it tries to detoxify a number of these compounds. And most of the time it gets that injury as a first organ in the body. The kidney is also involved in a lot of excretory processes during that process. And the small intestine, of course, from ingestion, most of the toxic compounds, the first cells to have the impact are cells or parts of the gastrointestinal organ. And the small intestine always has a number of these products staying for a longer period of time during the digestion process. So it's a good organ to assess in the first place in regard to toxicology. In terms of methodology, this slide is just to highlight the animal grouping of these subacute oral toxicity studies that we did and the treatment approach. As you can see in the table, we had 4 groups. The first one is the control group, which received corn oil as a vehicle. And then the 3 other groups, second, third, and fourth, are the treatments. So the second one received the heated low dose TMO at 50 milligram per kilogram body weight. And this was given by oral gavage daily for 28 days. The third received a heated high dose of the oil at 500 milligram per kilogram body weight. And the fourth received the unheated high dose of the oil at the same dosage. So the difference between group 2 and 3 versus group 4 is the heating of the oil. So we actually tried to mimic what happens during the deep frying process. In group 2 and 3, we had to repeatedly heat the oil and fry chips so that we could mimic what happens during the cooking process, so that we got the heated oil versus the unheated TMO in group 4, just to try and see if there is a clear impact of eating on the oil during this, and so that we make comparisons. And overall, in regard to the overall study design, I've said it's a subacute toxicity study. It's well defined by what we call the OECD guidelines, number 407. So it takes 28 days. The 4 groups that I've described, we had actually 5 rats in each group, and we had both males and females separate. So in total, we had 40 Worcester albino rats. Before the study, they were acclimatized, and then we grouped them into the 4 groups that I've described. The study took 28 days, and daily, what we had to do is to note any physical observation. And here the observations which are key issues like the animal behavior, aggressiveness, alertness, the appearance of the skin, the fur, and such. And then on weekly basis, we were determining the body weight. So we would determine that after the end of 7 days, 4 times, therefore, during the 28-day treatment. So we did the treatment that I've described, the 4 groups, the normal versus the 3 TMO treated groups. And at the end of the treatment, the animals were humanely sacrificed. And we were able to collect blood on one arm, mainly on the left side of this chart. And from the all blood, we assessed the hematological parameters. And there, mainly the red blood cells, the white blood cells, the hemoglobin, hematocrit, platelets, and many other parameters. That's a classical hematological parameter profile that needs to be done. And on the other hand, we process serum to assess mainly the liver function indices represented by alanine transaminase, ALT, total protein, TP there, albumin and globulin, and also glucose. And then for kidney function indices, we assessed mainly the levels of urea and creatinine. We also collected the tissues after sacrifice. And on one arm, I've said we assessed the malone dihaldehyde, a lipid peroxidation index in the liver cells, tissues. And we also got the tissue sections of the liver, the kidney, and the small intestine. And we processed the histological analysis to see if there were any changes. So overall, this is the overall study design. So this study, we have actually published the results as indicated here in Elion. And so the subsequent slides, I will just take you through the results from this subacute study that have just presented the overall design. So in the first set of results, we found some changes in the body weights of the rats at the end or during the treatment, because we were assessing the body weights weekly. So what you are seeing there are 2 figures. There is the figure A on the upper part, that is results from assessment of the male rats, the body weights of the male rats, and the lower one is for the female rats. So I'll start with the upper figure on the body weight changes in the male rats. Of course, the y-axis there is the body weight of, and the x-axis is the days, as indicated. Again, remember we had 4 groups, control, and the 3 TMO treated groups. And what we found out as the key finding here is from our control group that did not receive any TMO, they had a very steady increase in body weight, which is desirable, very normal. And that's represented by the solid continuous line that you're seeing. So there was a steady increase in body weight throughout the treatment period of 28 days. The other 3 lines which are broken are all for the treated groups which received TMO. And what we also found out is there was a steady increase of their weights up to 14th day. And then there was a general decline of their weights from 14th day to 28th day of the treatment period. When we did statistical analysis within these groups, it wasn't really statistically different, but at least you're seeing that there was a general pattern. Mainly the one I want to highlight is the decline of weights in the treatment groups of rats that received the TMO from the 14th day going to the 28th day. When you make a comparison with the female rats, it was almost the same profile. Actually, it's the same. The control groups in the female rats had a steady increase in weights. And then the treatment groups again gained some weight to 14th day, and then a general decline was coming in after the 14th day. So what this indicates is a decline in weights is usually an indication of already some systemic effect coming in the rats. Mainly, it could be a toxic effect or a side effect of the treatment. And so that's a pointer of something going on. And for this case, it's not very desirable. So the results that I've not shown here are from the physical observations that we were making daily, which I just want to point on a few observations because it's in line with body weight. And I'll say that we didn't have any mortality throughout this treatment. And the animals, all of them really were a bit alert, which looked like they were normal. But there was one key observation that we saw on the TMO treated groups, both male and female rats. From the 14th day, the skin fur started to peel, and the fur remained very rough to the end of the study. So this was coincidental with what we are seeing with the body weights. Around the 14th day, you're seeing some kind of decline. And then we were seeing those changes in the skin of the rats. So again, it could be pointing on already some systemic effects that were coming into play. Of course, no mortality or rats being alert could mean it can be taken that they were normal, but sometimes because this is a very short study, 28 days, it could just be indicative that some symptoms were delayed. If you do the study longer, you can see some of the effects again coming in with a chronic study. The next set of results that we found out were the changes in the blood cell count. And here the indicators were the hematological parameters in the whole blood. I've not shown everything. The publication has a detailed table with all the parameters. I'm just projecting here for the white blood cells, the red blood cells, the hemoglobin and the platelets. Again, we had the 4 groups, both male and female. And the main highlight that I just want to highlight with some statistical significance is on the red blood cells, mainly on the female rats. We saw some increase in the high dose of the heated transformer mineral oil treated group. Their red blood cells count was a bit high, and also hemoglobin for their knitted high dose. The hemoglobin levels were slightly a bit high compared to the control. So what could this be indicative of? Actually, it's a protective kind of result because the animals sometimes have physiological adaptation to treatments, and this angled or was leaning towards protection, which could be a good thing. But again, you can see that these changes could be already coming in because of the systemic effects that were arising from the treatment. For the platelets, mainly with the male rats, you can see that there were elevated levels in the platelet count, mainly on the high dose of the heated transformer mineral oil group and the unknitted transformer mineral group on high dose. And this could be indicative of some potential blood clotting problems that were coming in. Though when we looked at the clinical ranges of the platelet count, it was still within the normal range. But of course, it's worth noting that there were some changes statistically. So the other parameters that have not shown, there were some slight changes, very modest, but there were slight changes in those parameters. So again, indicating the potential of the TMO treatment in inducing some of these changes in the blood cell count. The next set of results was on the, first of all, I'll start with the liver or hepatic function indices, which we determine in serum. And I've also, I'm projecting the first group. The next slide will have more. Here we have alanine transaminase, that's ALT, total protein, albumin, and globulin as liver function indices. Again, we have the 4 groups, and all the groups again had the male and the female rats separate. And what I just want to highlight is the first row there on alanine transaminase. It's an enzyme which is very active in the liver. The levels, we found the levels were reduced significantly when compared to the control, mainly in the male rats. And for total protein, I'll also point on the levels of the IDOS, ETED IDOS transformer group. The levels were elevated, mainly in the females, and same with albumin. The levels were elevated in the same group in the females. So globulin, we didn't really see any difference in all the groups and between the males and the females. So what is this indicating? The first group, alanine transaminase, we could not clearly explain this scenario, and this warrants further investigation because the hypothesis is when the liver is injured, the levels of alanine transaminase, even total protein, albumin, globulin should be elevated because the liver cells are leaking some of these molecules to the blood or to the serum. So this one was an isolated case. But however, the total protein, you can see the elevated levels, and the albumin, the elevated levels, is a pointer of some toxicity. Though we could not clearly see a dose response effect, and even variations in gender was not very clear cut, but this is already an indicator of some liver injury. And I will also emphasize that when I get to the histology, because we assessed the histology of the liver. Still a continuation, mainly on the liver function indices, is on the fasting glucose and the liver MDA. And what we found out, mainly in the female rats, you can see the levels of glucose were a bit elevated compared to the control, which was statistically significant. Same to the liver MDA, we mainly found in the high dose groups, whether heated or uneated, in male and the females, mainly the males, all of them were affected, and you can see the level of the MDA, malondialdehyde, was elevated, and also elevated in the female group, mainly in the uneated high dose group. So what's the indication of this? Again, the first one for the fasting glucose, stress and metabolic changes from toxicants, sometimes stresses up the liver, so it induces metabolic changes like production of glucose and release to the blood, and that's why the elevation can come in. And the other player could be cortisol. Cortisol is an hormone that is usually secreted under stressful condition, and it affects metabolism. So that can be something arising from that. The liver MDA, I've said the malondialdehyde is an oxidant, and when the liver cells are under an oxidative stress, which could be caused by the constituents of TMO. It attacks the lipids in the membranes of the cells, mainly in the liver, and release of these oxidants. One of the end products is MDA. So this could be explaining this kind of scenario of elevated levels of MDA compared to the control groups. In regard to the renal or the kidney function indices of toxicity, we assessed urea and creatinine, and I'll say that we saw a very modest effect on the levels, except I want to just point on creatinine, mainly on the IDOS, heated transformer oil group of the female rats. It was significantly elevated, and this could be a pointer of the kidney having or being compromised in terms of excretion of creatinine, and so it tends to accumulate in blood. So that could be again a pointer on the renal effect, but I'll also show the histological changes that we or state of the kidney that we also did. So what I presented before I proceed with this slide is much on trying to assess the systemic effects in the blood, all blood, or in serum. And that's usually required during toxicological studies. But during treatments of animals with compounds potentially that can be toxic, or any treatment, the animal sometimes tends to physiologically adapt, and there is many interplay of many hormones and many adaptations that can occur physiologically. So especially for a very short-term study. So sometimes it's really good to do histology so that you can really see what is really happening again at cellular or at tissue level, because what you see in the serum can be masked by some other interplays that are coming in as the animals try to adapt before you see the long-term effect. So that's why we did histology. And this slide is showing the photo micrographs of the sections of representatives of the liver, the kidney, and the small intestine. I will start with the upper panel. The upper panel is for the liver. The middle one will be for the kidney, and the lower one is for the small intestine. Again, these are representatives of the 4 groups that we had during the treatment, and the first one down will be all control groups, and then the 3 treatments, the low dose of the transformer mineral oil treated groups, the heated IDOS, and the unheated IDOS, just like that. So to start with the liver, what we found out from the control group, I hope you can see the arrows. It's pointing to some of the significant sections that I will highlight. For the control group of the liver, they were normal, and what is pointed out there is a portal triad, which is a very desirable thing to see in a normal functioning liver tissue. So that then the rat said the normal control group had normal liver tissues. The treatment groups, the low dose, they had already, or we saw what we call periportal chronic inflammation as pointed around there. And the heated IDOS had also some what we call the bile duct proliferation, which is always an indicator of some toxicity. The unheated IDOS had also inflammation, periportal chronic inflammation, like the low dose. So inflammation and this bile duct proliferation indices or indicators of tissue damage. And if we relate to what we saw with the serum analysis, it's in agreement, because I highlighted that the total protein and albumin were elevated in the treatment groups, and that elevation could be an indication of liver injury, and this could be the contributors that we are seeing: inflammation, bile duct proliferation, and then the tissues, the cells are leaking out some of those compounds that are very rich in the liver, but then they get to the blood. I also pointed out on the liver MDA that was elevated. That's an indicator of oxidative stress. Oxidative stress can also bring in inflammation. And so that is just to support the serum analysis and what we found out with these cases of inflammation and bile duct proliferation that we are seeing in the treatment groups. Now, in the middle is the kidney, and the control group had normal kidney, as highlighted by the normal kidney tubules that are pointed out there. For the treatment groups, the changes were very modest when we compared to the liver. So like the low dose had a normal kidney with normal glomeruli. If you can see that, those are glomerulus in these sections, which are a clear indication of a normal functioning kidney tissue section. For the heated dose, however, we saw some mild chronic inflammation at those points pointed. Those are mild points of chronic inflammation, and the uneated dose group actually had a normal kidney. So that's why I'm saying the changes were very modest, except these heated dose that we noted the mild chronic inflammation. So these results could be suggesting what we also saw with the serum analysis of urea and creatinine, which are indices of how the kidney is functioning. We also found very modest changes or no changes at all in urea and creatinine, except a few that I had highlighted. So it could be an indication of this finding that the kidney was not majorly altered. The lower section is the sections of the small intestine. The control group here had a normal section of the small intestine, and this was critical. We got the sections of the small intestine because we treated the rats orally. So the first cells or tissues to come in contact with the transformer mineral oil are organs or tissues of the gastrointestinal tract. And the small intestine is one good one because the food, as it passes through the gut, stays for a longer period in the small intestine. So the control rats had a normal section of the small intestine. The low dose also had a normal section of the small intestine. What we call the prominent lymphoid follicles are pointed. It's a typical scenario in a normal section of a small intestine, so the impact wasn't much. However, we saw moderate chronic inflammation in both the heated IDOS and the unheated IDOS groups, sections of the rats. And what is pointed on those sections where we saw the moderate chronic inflammation, same to that. So inflammation in the small intestine is something to note, because most of the inflammatory diseases that occur in the gut, you will see the common scenario is inflammation of the mucosa cells of the gut. So it can affect any part of the gastrointestinal section. It could be the stomach, the large intestine, the small intestine. We didn't do all that, but at least we are seeing a representation of that from the small intestine. And it's something of concern to note that this is a possible toxic end of the treatment with this transformer mineral oil in the rats. So that summarizes what we were able to showcase through this subacute oral toxicity study and the changes that are highlighted in the serum, in the whole blood, in the liver cells, liver MDA, and now the histology. So in summary, what we arrived at is that there were alterations in the blood, in the liver, in the kidney, and the small intestine, though they were mild changes, mild alterations, but this is still indicative of the toxicity of this TMO following the treatments that we did on the rats by oral gavage. So because of this, we are also saying that the blending that most of the commercial vendors do with edible oils and preparing the foods through that mixture should really be discontinued, because you are seeing that these potential various toxicities that we've showcased, and it could be impacting even humans when they ingest that. Even though our studies are in rats, the rat model that we used is a good model to project what could be happening even in the human subjects. There are still studies which are still critical to be done. This was a subacute oral toxicity study for 28 days. It's done so that if you note any possible alterations, any possible toxicological indicators, you then progress to a chronic study. So we are still recommending that there is need to do a chronic study so that you follow up on even some of the delayed latency symptoms that maybe we could not see much during this subacute oral toxicity study. But mainly, we are saying the chronic study should be done because of the alterations that we've seen already within a 28-day study. And of course, maybe also explore on using other either high doses of TMO to really see the impact of TMO on cells and on tissues and on even the blood. They still need also on investigations through the chronic toxicity studies to study the pathophysiological mechanisms that are involved. And here I can state that some of the key studies that can still or really mechanisms that can be looked at during that toxicity study are issues like genotoxicity, carcinogenicity, and even what we call endocrine disruptions, because it's something coming up. It's very common with these hydrocarbons that they've been known that they can affect many of the endocrine organs or glands. So those are still areas to explore. We are still thinking about it also. But it's good we have published our work so that anyone can still explore also other potential mechanisms and studies following up what we've published. So at this point, I wish to acknowledge my co-authors. Grace Otunga was my former student. She actually graduated from our department with a Master's of Science in Biochemistry. My collaborators at Moi University, Dr. Mayo, Dr. Macharia, I think is now working with the MTRH here in Eldoret for their support and for working together in this project. I also wish to thank the National Research Fund here in Kenya for funding this work. The funding has really assisted us to explore what we were able to explore. And of course, I thank my University of Eldoret, where I'm best, for the support and offering us a chance to also explore research and do what we can. Finally, I want to thank the organizing committee and the secretariat of this conference, which is actually hosted by my Department of Chemistry and Biochemistry, for again honoring me to be a keynote speaker. And I say thank you very much. Thank you everyone for your attention. I think I'm ready to take up any comments or questions. Thank you very much. Thank you.
Yeah, Dr. Tuyei, that was a wonderful presentation, which breads well with the theme of the conference, as well as the sub-themes on food and health. So you have educated us, and at the end, you have concluded that subacute oral administration of TMO induced various degrees of dermal, hematological, hepatic, renal, and small intestine toxicities in rats. So that one now is a question to the policy makers. Now, at this point, I wish to open the plenary for any question, comment, or clarification. I can see a hand by Dr. Bisem. Dr. Bisem, you can go ahead.
Thank you, Chair. Thank you, Chair. And thank you, Dr. Tuyei, for a very informative presentation. I have one comment. Even though it was minor, we are seeing damages to the liver, to the kidneys, and to the blood cells. So it will be interesting to look at long term, especially because even though it was minor in the kidneys, kidneys usually follow damage from the livers. So probably with a longer study, you'll be able to see greater impact on the liver that will further impact the kidney. Now the other question, the other comment or say question that I had is because hydrocarbons are most likely lipid soluble, and one of the destinations of lipids is the adipose tissue. And we were able to see that there's a loss in body weight that may indicate toxicity and may indicate some impact on leptin secretion, which we know leptin is a hormone that regulates body weight. So I would like to just ask you to make some comments on that. What do you think about those possible impacts and maybe toxicity to the adipose tissue, and also to the pancreas as well, as we saw inflammation in the bile duct. So do you see a possible impact on the pancreas? Thank you.
Yes, I am. Should I answer or?
Yes, please go ahead.
Okay. So thank you, Dr. Bisam, for your comments and also questions. I think you've highlighted why it's critical to still do long-term studies because the liver, the kidney, when we do long-term studies, we could even assess more of the impact because we were already seeing changes in this short-term study. You had a question, I hope I got it right, that it could be possible that this TMO can impact the adipose tissue, which is truly an endocrine organ also, and probably affect leptin and adiponectin and many other hormones secreted by the adipose tissue. But you had a specific question mainly on leptin and body weight. Of course, we didn't do this, but what I'll actually say is that I think you are seeing towards the end of the study, the body weights were kind of declining, not really increasing. So it was a decline much on the body weights. And from our thinking, it's much of maybe cortisol coming in because cortisol breaks down much of the fats and other storage fuels. And that's why it can impact on the reduction of the weight. Leptin, on the other hand, from what you are hypothesizing, if the oil accumulates and in the adipose tissue and all that, leptin is usually elevated when the adipose tissue is also building up. So that doesn't seem to come into play so much. But I'll say in a chronic study, then, it's possible to really do much on this endocrine disruption and even assess levels of these hormones, leptin and others, adiponectin, resistin, and even do now more studies on the histology of the adipocytes. So I hope that answers that. On my thinking about the pancreas, of course, we did not do any indicator of the pancreas. We did, of course, glucose, but as you know, glucose levels are not directly, or sometimes the levels could be an issue of the liver. And I pointed on again that cortisol could be the player, so that you have gluconeogenesis. The liver is synthesizing much of the glucose, breaking down glycogen, releasing it into the blood, and that's why you have elevated glucose levels. So I'll say in a chronic study, maybe a better assessment will be done, and then that discussion can be addressed better by assessing the pancreas and other hormones, the insulin and glucagon, and so from the in blood during that assessment. I hope I've answered you, Dr. Bisson.
Okay, thank you. Yeah, thank you, Chair, Mr. Ndegwa. Thank you, Dr. Tway, for the educative talk. I think we need to see how we can maybe come up with a policy paper on this, because cases of transformers being vandalized with the name of stealing this transformer oil has been on the increase. So I think there's a need for us to inform the public of the toxicity associated with the oils as you have presented in your studies. And then I would also want you maybe to propose what are some of the ways that can be done to discourage the public from using the TMOs, now that we know that they are not friendly in terms of usage for preparation of food. Thank you.
Chair, can you hear me? Chair? Mr. Ndegwa? Yes?
What I'm saying is, you wait for Dr. Wambu to raise his question, and then you can answer him together with Professor Luther.
Okay.
Yes, go ahead, please.
All right. I think there's I was muted, so All right. Dr. Tway, that was an outstanding presentation. Very elaborate and very informative. We are more educated than we were this morning. My question is the general one. It is about the controversial issue that you commented about of lessing the food for the youth with the kerosene or a paraffin. So I just wanted to find out, do we have any established biochemical effects of paraffin when it is consumed? Or have we had any study to establish if the alleged effects are authentic or unauthentic? Thank you very much.
Okay, I think, have we gotten that one? Maybe you can
Yes,
answer
Chair.
those ones. We'll go to Caroline later on. Just answer those ones first, please.
Okay. Thank you. Thank you, Professor Luta, for your comment. I think the first one, you are making a suggestion about the need for policymakers to be made aware. I think what we are doing by also holding conferences like this and can have an impact somehow, because some of these people, this can get out to some of them in different medias. The other one was much of a question. You said, how can we discourage the public from doing the blending and vandalizing transformers and selling them to vendors for their use in cooking? I think that is an issue of public awareness. As a scientist, I think it's a bit hard for some of us who are in the real science to be involved in that so much. But I would say it's really public awareness, and it's much about also working with policymakers so that they can support such kind of programs, which can be done through, it can be through the media, through trainings in the grassroots and all that. So we really need a goodwill of also a number of stakeholders, the government involved, the Ministry of Health, and for that kind of public awareness platform to be done. So I think that's something that needs to be done, of course. For Dr. Wambu, thank you for your comment that the talk has been informative. Thank you for that. Your question on if there are any established effects of using kerosene or through ingestion, like what is done by lessing this kerosene in foods in high schools, I would say there are some of these publications on well-established effects of kerosene. And what I'll say is that to arrive at this conclusive effect, sometimes you need to pull the studies from individual components of what is found in some of these products, because doing all studies, sometimes you don't get everything. But there's one of my co-author, Dr. Mayo, actually did a study in rats, and they found the contrary, that actually when you treat rats with kerosene, the testosterone, it was male rats, the testosterone levels were elevated, meaning it made them more aggressive. So it was even doing the opposite of what people think it should be doing, reducing aggressiveness, which is driven, of course, by most times hormones like testosterone. So there is well-established effects of kerosene. In fact, we've authored a very elaborate review on the effects of kerosene, and it ranges from a lot. Some could be potential carcinogens, but others were not just being carcinogenic, it was affecting other parts of the body, the gastrointestinal system, the kidney system, and all that. So it's not good at all to have kerosene exposed to human subjects. And some of the exposures could even be through the skin, through inhalation and all that. So the exposure route can differ and the impact can be different. Thank you. I hope I've answered your question, Professor Lucha and Dr. Wambu.
Another question, Dr. Bisema has raised her hand on behalf of Ms. Caroline. Ms. Caroline, can you go ahead?
Okay, I'm using Dr. Bisema's computer. First of all, I want to thank you, Chair, and to thank Dr. Tuwei for the great insight in this area of public concern. Huh? I'm unmute. Okay, sorry for that. Chair, I want to thank you, and I want to thank Dr. Tuwei for this great insight in this area of public concern. Now, previous studies have shown that overeating of cooking oil tend to form radicals, which tend to attach on the food that have been used to cook. So I wanted to know, you talked about the transformer oil being very stable. I wanted to know, does it also form radicals when it is overeated? And now when it is overeated, the food that has been used to cook could also contain those radicals. So is the toxicity associated with the benzoic components present in the transformer oil, or the radicals could also contributing to the toxicity? Thank you.
Mr. Degwa, should I answer that, or I'm checking more questions?
Please, you can answer that, but in the also you can. There is another question on the chat, which was raised by Ayabei, which reads, can we use the same approach to establish toxicity of traditional concoctions, isolated natural products, and synthesized nanomaterials? What could be the challenge of carrying out the study within UOE? Maybe you can answer those two questions.
Okay, thank you. So for Ms. Caroline, I think the question is about the eating process of edible oils, and also now what we are saying, some of these edible oils is actually left with the, or mixed up, blended with the TMO. So what I'll say that during the eating process, the compounds that are being altered are really what is being produced during that eating process from the oils itself, whether it's edible oils or the TMO. So during the eating process, it's true, there are many molecules that are being produced which are potentially very oxidant in nature. And of course, again, remember during the eating process, you're having also the foods that are being processed in that eating process. So it's a mix of all that. But what we are keen on is the oxidant product that now when we ingest gets also into our cells and we can absorb them. So the end product of those oxidants will be a mix. I've said, like for TMO, it has these complex constituents, which are just polycyclic aromatic hydrocarbons and many other chemicals. So in the process of the eating, it can also be producing oxidants or reacting with the foods and having all those oxidants building up, same to edible oils. So I think that's the point. And the intense eating and repeated eating is one of the drivers for that chemical processes that occur before we now ingest the foods. For Dr. Ayabe, your question is about assessing toxicity of concoctions or even the crude isolates that we get from maybe plants or phytochemicals or synthesized derived nanomaterials from maybe even plant-based and all that. Yes, toxicity, the approach is still this. It's either you do an acute toxicity study, subacute, chronic, and if it's through ingestion, then it has to be through ingestion, unless for your study, if you're saying you are applying something topically, then that study has to be done with the exposure route being a topical maybe application. So the approach is the same, and some of the toxicological endpoints that you have to assess is also based on what you understand about your treatment and the possible implication that it can have in the body. So let's say if you think it's potentially an oxidant or it can produce such, you need to assess all that. But of course, that is usually done to just assess if some of these concoctions have, or at what level, at what dose can it induce toxicity. So that could be an approach. At UOE, the challenges will really be much on how do you assess some of the parameters. You can do the animal studies and all that. At UOE, we did the animal studies. We did the treatments of the rat, but most of the assessments, the laboratory assessments, you have to do it elsewhere. Like for most of the blood assessment, the histology assessment, we did much at Moi University and also at MTRH. And a few at UOE where you can really do it. So they can be that limitation, and so you really need to know how to collaborate and try and see how to do much of the others. Sometimes you have to get to Cambridge for some of those, some of these assessments. Thank you.
Commented on your very good work, including Dr. Mayo. He used to be one of us, I think, some times back. I can see Professor Samuel Luta is still raising his hand. I think he is not tired. Okay, thank you. Yes, so I think that was a wonderful presentation, and we thank you. There is one more.
Thank you,
yes,
Mr. Ndegwa. I hope you are seeing the chat. I'm not able to quickly, I hope I've answered. I'm seeing there are questions in the chat.
Yes, Daktari, there is still one more question from Mr. Kamau. And he says, thanks for the detailed presentation. Question, what is the conventional treatment of someone who has taken and is affected by TMO, and what are the symptoms to watch out for? That's a good question. I hope, have you gotten that one?
Yes.
Okay.
Okay, so I think what Mr. Kamau is saying is could be an issue of poisoning because for very adverse effects to be seen, it could be an issue of someone being really intoxicated, whether intentional or unintentional. And for that, I don't have a very very definite answer. I'm sure it will be an issue of hospitalization. The problem with TMO is it's an hydrocarbon. There is tendency of it bioaccumulating in tissues, and I think if it has been absorbed into the system, that will be issues to address, and hopefully, if it's not very lethal, hopefully it's something that slowly the body can detoxify. But if there are clear impacts, I'm sure it will be handled at the hospital at that case. So I think those will be extreme cases of mainly poisoning and such. And it depends on the exposure route, whether it was inhaled, it was ingested, and those will be addressed appropriately with that.
Are you looking towards pursuing a project to study human subjects exposed to prolonged use of TMO?
Okay. I think that's by Dr. Bissem, I'm seeing in the chat.
Yes.
Toxicological studies are approached in different ways with molecules that are potentially toxic. The best is to use models, not really human subjects. And even this, I mentioned about the EFSA, the European Food Safety Authority, and all this. The models will still be best with animal models, because you don't want to do a study on human subjects with a potentially with compounds that can be potentially toxic in different ways. So I'll say it will still be an approach with a rat model, probably. And for cases of human subjects, the way we bring in all this toxicological assessment is instances, let's say, of case reports, whether it's poisoning or some long-term exposures in the workplace and such, so that such subjects can be followed up and assessed on the potential impacts of the exposures of those components. So I think that's what I'll say.
Okay, thank you very much. Thank you. I think we are going to end there, and we thank you again for such a wonderful presentation. A clap.
Thank you.
Thank you very much. I now wish to stop there and hand over to the head of the department. Thank you, Dr. Wambu.
Mr. Ndekwa for leading that session very well. We are drawing to the end of our conference. And I think our DVC, ASA, is already with us online. So I just wanted to invite a few people to make their remarks. Is everything all right? Okay, thank you. All right. Am I okay? Yes. So I was just saying we appreciate everyone that has participated in this conference, those who have attended, and they that were able to present their very wonderful results to us, and more so the keynote speakers, and also our VC who was able to find time to be together with us. So at this juncture, I wanted to, first of all, I know the chair is outside, the chair of the planning committee. If somebody would get her, I wanted to give her a moment just to make comments, because they have worked tirelessly. I've done very little myself. It is them who have been on the ground, and I find that it is befitting that I give them an opportunity to say something, even as we draw to the close of the conference. So Dr. Samita, I know she's around. We give her a minute or so. Yes, Dr. Samita, I want you to find space. Just sit somewhere and welcome, Dr.
A few remarks, having been the chair of the organizing committee. So I didn't work alone. We worked as a team. So at this point, I want to recognize the members that I worked with, because without them, we wouldn't have been successful. So first, the committee had the following members. We had Dr. Geoffrey Kipto as our secretary. Then other members were Dr. Kiplagat Ayabei. We had Dr. Stephen Barasa, Dr. Enos Wambu, Professor Maurice Okoth, Professor Lusweti Kitui. We had Mr. Kennedy Kamau. Now, I want to thank all of them. They played various roles. We also had Dr. Naomi Bisem. So all of them played different roles, and they worked tirelessly to ensure that we did succeed. So to all those members, I want to say a very big thank you. Then a special thank you also goes to the HOD, who was a member of the committee, but because of his support, he was very supportive. We were consulting him a lot. He guided us, and we want to say a big thank you. Then also the dean, who was a member of our committee, Professor Samuel Luta. We did consult him a lot. He directed us, and we learned a lot from him. So also I want to say a big thank you. Then lastly, I also want to recognize the ICT team. That is consisting of Mr. Albert Onyango, Mr. Franklin Ngatia, Mr. Rogers Koech, and other members of the team. They worked tirelessly to ensure that this conference was, the transmission was seamless, and it has been a success. So to the ICT team, a very big thank you. Then also the Directorate of Research and Innovation, Professor Sudoi, Ms. Emily Kerich, a very big thank you to all of you. Your contributions cannot go unmentioned. And then lastly, I also want to thank members of the chemistry department at large. Your contribution, your suggestions, were really helpful to us. And I'm sure it made our organizing efforts successful. So a very big thank you to all of us. I think that's all I'll say. Return back to the chair of the session. Thank you.
Thank you very much, Dr. Samita, our able chair of the planning committee. Madam DVC, I know you are hearing us. I wanted to request for your indulgence, because apart from that team, the entire department has participated in organizing this conference. And I feel as their team leader, it is befitting that I introduce those that are here for the purposes of recognizing them. I request the cameraman maybe just to move the camera around. I know some of these people you might not be able to recognize them because they have been very busy. Maybe they have not come to see you. I will start from that extreme end. We have Alex. Alex, you can wave to Madam. Alex is our graduate assistant in biochemistry. We have Dr. Rango next to him. He's our lecturer in organic chemistry. We have Dr. Nyambu. Dr. Nyambu Sibora is our lecturer in analytical chemistry. Next to her, we have Miss Caroline Kosgei. Caroline Kosgei is our lecturer in biochemistry. Dr. Naomi Bisem, sitting next to her, our lecturer in biochemistry. Dr. Wetungu Martin is also our lecturer in organic chemistry. We have Mr. Joshua Kemei, very instrumental. He's our lecturer in biochemistry. Of course, Professor Lusweti, a well-known face, our professor in physical chemistry. Dr. Grace Lagat, lecturer in analytical chemistry. I don't know if I have to introduce my dean. Professor Luther is a professor of inorganic chemistry. We have Mr. Ndekwa, long years of experience in teaching organic chemistry. Then I will skip the director and go to Dr. Ayabe. Dr. Kiblagat Ayabe is our lecturer in analytical chemistry. And lastly, we have Mr. Kosgei James, who is also our PhD student. He was presenting very serious results yesterday. So, Madam DVC, I just wanted to introduce them to you and also to appreciate them for the great work that they are doing and for the team spirit. At this juncture, Madam, may I therefore invite our Dean, and I think, yes, to make his remarks, and then he will invite the director. Dean, you can come here. How about that?
Thank you. Thank you. Thank you, Dr. Wambu, HOD Chemistry, and all the participants for this conference. We have had a nice learning session. I think I'll not say much. I also want just to thank our DVC for finding time to be with us. I saw she attended the last talk, and that was quite encouraging.
I think my task is simple, is to invite the Director, Research and Innovation, who will in turn invite our DVC ASA to officially close the function. I know we have been here for some time. We'll be able to catch up on other things as we move along. So welcome, Director, Professor Sudoi.
Ladies and gentlemen, I would like to give a few remarks on this Chemical Society conference, which started 3 days ago. I must say it has gone on very well. And it has gone on well because of the organizing committee, who have actually done a lot of work. I must thank the chair, Dr. Samita, the DVC's office for their support, DVC Pre for the support. We had a number of keynote speakers whose names I cannot mention here. We also had parallel sessions who were chaired by session chairs and rapporteurs. I'm sure this virtual conference would not have succeeded without the members of ICT who have really been here with us, the Secretariat who kept preparing for the program and even now still taking a lot of notes. We were also streaming in YouTube. For those of you who didn't attend this conference, you are invited to the YouTube after this, University of Eldoret YouTube on Chemical Society Conference. As I end these remarks, I want to encourage all the participants to make sure that their work which was presented here are eventually published in reputable journals. This will give us a visibility, and as the Director of Research, we are always ready to support. Thank you very much. At this juncture, I would like to welcome our DVC ASA, Professor Otunga, to give her closing remarks. Welcome, Prof.
Thank you very much, Director, Research and Innovation, at the University of Eldoret, Vice Chancellor, Professor Teresa Kenga. I'm glad that she managed to attend. Other members of University Management, the keynote speakers, participants in this conference, organizers of this important conference, ladies and gentlemen, good afternoon. As you have been told, let me introduce myself afresh. I'm Professor Ruth Otunga. I'm the DVC in charge of academic and students affairs. I must say it has been a great pleasure to welcome you all to our University Virtual Chemical Sciences Conference on the theme Trends, Innovations in Chemical Sciences for Sustainable Development. Over the 3 days, we have had robust presentations from various researchers, fields ranging from food and nutrition, security, health, environmental conservation, and climate change, industrial processing and manufacturing. The United Nations Sustainable Development Goals aim at ending poverty, protecting the planet, and bringing peace and prosperity to all. Indeed, from the presentations, which of course I managed to sit in the last one, From these presentations, the role of the chemical sciences in providing solutions towards achieving sustainable development goals was clearly demonstrated. There were three emerging areas of agreement from this conference. One, there is a need to push for prospection of new drugs, particularly antibiotics in sub-Saharan Africa. It was emphasized that researchers in sub-Saharan Africa should explore new methodologies methodologies such as computer software-driven bioprospection that requires little resources while screening large numbers of potential bioactive compounds for treatment of emerging diseases such as coronavirus, which of course we refer to easily as COVID-19. Then two, there is an emerging silent crisis of water pollution from contaminants such as pharmaceuticals and pesticides. There is need for governments to develop policies on use and disposal of these products. As researchers, we can provide policy briefs which will serve as advisory to governments on how to address the issue. There is great impetus for us to collaborate and further research to develop innovative solutions to conserve and protect our environment from emerging pollutants. Three, the need for continued and enhanced collaboration across different institutions and countries for greater research and information dissemination. It was also resolved that more effort be made to incorporate and mentor women in science research. In my assessment, the conference was a great success. I extend our heartfelt gratitude to the keynote speakers for accepting our invitation and for their inspiring presentations. I thank all the researchers who shared their findings and all our attendees. It is my hope that this has been a very enriching experience, that you learned something new and made new connections for potential new collaborations. I appreciate the University of Eldoret management, led by the Vice Chancellor, Professor Teresa Akenga, for sponsoring this conference, and the University of Eldoret Town Campus for hosting this important event. I appreciate the organizing committee and the Director of Research and Innovation, the ICT department, and the Corporate Affairs and Marketing department for their tireless efforts to ensure the success of this conference. I now declare the conference officially closed, and I thank you very much for very productive engagements in this conference.
I'll now invite Dr. Bissem to move the final vote of thanks.
Thank you very much, Chair. Mine is to reiterate our thanks. So to the Professor Otunga, our DVC ASA, all protocols observed, ladies and gentlemen, it is my greatest pleasure to give the vote of thanks as we bring this conference to a close. Firstly, I would like to thank the good Lord for his grace and favor through these 3 days. Secondly, I would like to express our heartfelt gratitude to the keynote speakers, Professor Teresa Akenga, our Vice Chancellor, University of Eldoret, Professor Christophe Dimistri, Associate Professor of Bioscience Engineering at the University of Ghent, Belgium, Professor Rajeshwara Achur, Professor of Biochemistry, Kuvempu University, India, Professor Josephat Matasio, Professor of Organic Chemistry, Egerton University, Professor Hudson Nyambaka, Professor of Analytical Chemistry, Kenyatta University, Professor John Lusweti, he's a Professor of Physical Chemistry at the University of Eldoret, and Dr. Tuwei, Lecturer of Biochemistry at the University of Eldoret. We appreciate you taking the time to share your knowledge and expertise with us. I also sincerely thank the participants for choosing this conference to present your work, and the attendees for joining in the discussions. I appreciate all the chairs and rapporteurs of sessions for your able running of all the various sessions. Thirdly, I express our appreciation to those who made this conference possible. The University Management, University of Eldoret, led by a very able Vice Chancellor, Professor Teresa Akenga, for sponsoring the conference. The University of Eldoret Town Campus, led by the Director, Professor Lynette Gohole, for hosting us. The Deputy Vice Chancellor, Planning, Research and Extension, Professor Philip Raburu, and the Directorate of Research and Innovation, led by Professor Vincent Sudoi, for your guidance, direction, and support during the planning of the conference. The Department of Marketing and Corporate Affairs for providing marketing and awareness and visibility of our conference. The Director of ICT, led by the Directorate of ICT, led by the Director, Dr. Victor Kimeli, and the ICT team for providing the ICT support that made the smooth transmission of this virtual conference a success. Last but not least, I appreciate the conference organizing committee, led by the chair, Dr. Fidelis Samita, for your tireless efforts, planning, and execution that made this inaugural chemical science conference by the Department of Chemistry and Biochemistry a success. With these remarks, I invite Professor John Lusweti to give the closing prayer as we end. Professor.
Thank you very much, Dr. Bissem. We have a small variation. We will arise to sing our national anthem, one stanza, and the East African anthem, one stanza. Then Prof will conclude.
Let's pray. Our Father and our God, we give thanks, we honor you, we appreciate you, King of kings, Lord of lords. You are the everlasting Father who never changes. You are the same yesterday, today, and forever. We thank you because you created us, you gave us talents, you gave us knowledge, you gave us understanding, and as people who fear you, we say you are worthy of our praises, you are worthy of our thanks. When we started this conference, oh God, we invited your presence, and you indeed have been with us. And we are saying thank you for what has taken place. We thank you for the planners. We want to thank you for the organizing committee led by the chairperson, Dr. Fidelis Samita, and her team. Father, how they worked hard to ensure that this conference succeeded. We thank you for the ICT team. Thank you for the administration led by our professor, the Vice Chancellor, Teresa Kenga. Father, we thank you even for her deputies. We thank you for the directors. We thank you for the Dean of Science, Professor Luther. Thank you for HOD, Dr. Wambu. We want to thank you for all the participants, those who followed us on Zoom, those who attended physically, and above all, Lord, we remember them that shared their knowledge, their findings, their discoveries, and new information that we received. Father, we want to pray for each one of them, the keynote speakers from outside and even from within. Thank you for every individual that shared the discoveries. We thank you, Lord, for giving all of them the energy, the understanding, and even the willingness to share with what they have. Father, we thank you even for the listeners, the chairs of sessions, the rapporteurs, and all, Lord, that were involved, even the catering and even the buildings here. We thank you for the director. Father, we are saying thank you because all started well with you and we have ended well with you. Father, all the glory and honor will go to you. We also remember, even as a department, that Father, this is just the beginning, that we shall have more opportunities which are ahead of us, that we continue with research, we continue with the discoveries for the betterment of our society and even for our students. Father, we want to pray that this department will grow, it will blossom in future, that even our products, who are our students, will be well sorted for because of the information, the knowledge that they would have received. Father, now we are saying, as we come to the end, may you protect each one of us. As we depart from this place, disperse us with your love, disperse us with your strength, and let the Holy Spirit continue to guide us, and as a department, we shall remain united and serve our institution. We want to thank you that what is ahead of us, we shall arise and occupy and possess, even as lecturers, as professors, and all of us who are involved, that we shall be productive for the betterment of our society. We want to thank you. We give you glory and honor. It's because we have prayed and believed in Jesus' name. Amen. Thank you.
Recording stopped.